Hello, everyone, and welcome. Good morning, good afternoon, good evening, but depending upon where you are. We have a lot of people who have registered for the conference. We'll go ahead and get started. I will kick off. I will spend maybe another 5 to 10 minutes on setting things up, and then I will hand it over to our first panelists. Get started here. Okay. And okay, so once again, welcome everyone. Thank you so much for being here. My name is Raja Iqbal. I am the Chief Data Scientist at Data Science Dojo, and I'm going to be the MC for this conference for today and tomorrow. So first of all, we have more than 51,000 people who registered for the conference. So that's, and we had to actually stop registering because we were actually worried that we will not be able to handle the capacity, or our Zoom call will not be able to handle that many people. So first things first, I would love to actually know where is everyone joining from, because our own analytics actually showed that we had people joining from every single country and territory on the planet. So if you can go ahead and scan, you can point and shoot, just use your mobile phone. Go ahead and scan and start entering wherever you're from, your country name, where you're based. Or you can also go to www.menti.com and enter the code, and then see where everyone is coming from. We'll come back and see this, look at the results of this poll shortly. Okay. So a big thanks to our partners. So we have a lot of community partners, many speakers, and then financial sponsors as well. So thank you, all of you who made this conference possible. So before I hand it over to the first session, right? It is an interesting idea. It is an interesting thought that I had, and then it turns out that a few other panelists, they also had this thought. What is agentic AI really, right? So is it just some buzzword, machine learning, AI, generative AI, agentic AI? So is really agentic AI something new? Is it something valuable, or is it something that has been there around, and then we are packaging it with a different name? Well, it depends upon how you look at it. At the core of agentic AI definitely is your generative AI. But if you look at it, the idea of agency, or something being an agent as opposed to an assistant, the idea is that an agent works toward a goal. So there is an aspect of a goal. When I go and interact with ChatGPT, well, I ask a question, or maybe early days of ChatGPT, right? So I ask a question, it just goes and gives me an answer. But an agentic framework, or an agentic application, will have a notion of a goal. If this happens, go and, well, use your memory and learn and do some reasoning and planning, and go and in an autonomous manner, go and execute this task. So do we use generative AI for agentic AI? Absolutely, right? So under the hood, the planning and reasoning happens using generative AI. That autonomy, the decision-making under the hood, you combine some of the standard web services, or the idea of different interconnected applications. Memory and learning, you have this idea of context. You gather context from your databases. You gather context from your session memory. You are basically looking at, okay, I asked a question. what is the capital of Paris? And okay, the capital of Paris is France. Then I go back and ask where is it located? And now, how does it know whether what it and what is it referring to when I say it? So that kind of understanding, that kind of context, it is built using what we call memory, and then context is from your traditional databases, your vector databases, and there's this notion of goal. Eventually, I want to send an email at the end of this, or I want to book this appointment as a result by the end of this. So the way we have organized the entire agenda of the conference is that we will start with something from all of these areas of agentic AI. So our very first session that is about to start in a few minutes, we'll talk about how do models, these large language models, the under the hood, call them the foundation models or the frontier models, the generic large language models, how do they actually plan and reason? How do they understand our intent? How do they structure the intent of what the question that was asked? So how do they plan and reason and go ahead and combine it from some information, combine it with some information from whatever the user is talking about, whatever the user or whoever is interacting with these agentic systems, how do they actually understand the intent? How do they get that context, the memory, some information in your healthcare database, your electronic medical record, or your CRM system, or your vector database, or your traditional SQL database? How do we actually bring all of these into action? So we have multiple sessions. The first session today is going to talk about the very first session today is going to talk about, it is going to focus on the planning and reasoning aspect of these models. The second session is going to talk about, once these systems become autonomous, how do we make sure that we have the right observability and right guardrails and the right systems in place so we can monitor these agentic workflows? And how do we keep them safe? And the third session of the day, and you will see me again in that session, I will be moderating the third panel, where we will talk about how do you combine these models with retrieval systems. And retrieval systems is going to be a broader term here. A retrieval system could be a vector database. It could also be a traditional SQL database. It could be maybe a graph database. How do you combine all of this? All of these models with with your context. This whole wave around model context protocol. I mean, that falls in this roughly in this category where you're building context and memory and learning. So how do you actually combine all of this to make your agentic systems more useful and meaningful? So without further ado, right? So if you look at this, so we have 4 panels today. I think I broadly talked about it. I forgot to mention the tutorial. We have a tutorial at the end of the day today, the last session. We will have a tutorial for optimizing AI agents in the cloud and on the cloud. So without further ado, I will hand it over to my dear friend, Sam Party. Sam, over to you.
Raj, always nice to be at another Data Science Central conference. Today we have an absolute panel of heavyweights, people that are on the ground floor of building agents, people that have experience actually doing this themselves, have large followings on social media. This is a group that will tell you exactly how, when, where, why to do exactly what you want to do with agents. Today we have Kartik, Victor, and Hamza, all 3 of which are exactly as described. I will quickly introduce myself and then allow each of them about a minute to introduce themselves as well. But mostly, I'm going to do my best to shut up and give them the chance to just fill this panel with their insight and expertise. So I'm Sam Parti. I'm the CTO and co-founder of Arcade.dev. And without further ado, Hamza, why don't you start us off?
Hi everyone. First off, thank you for having me, Sam and Raja. Great to meet you again. My name is Hamza. I am a founder of a company called Traversal.ai. We build data science agents, and we also work with enterprise knowledge management. I also teach with SPD at Stanford, and I'm also an adjunct at UCLA.
Victor?
Hey everyone, hopefully you can hear me. My name is Victor. I'm a research software engineer at Microsoft Research. And essentially, my connection to Agent is that about 2.5 years ago, there's a group of us who were sort of excited about exploring new ways of building software. And one way we sort of explored that was that as opposed to the developer explicitly building a set of steps which might include LLMs to solve a problem. How about we define the set of agents, give them some tools, and sort of let them explore any arbitrary problem space by exchanging messages. And so all that work sort of culminated in AutoGen, which is an open source framework we built in multi-agent applications. And the space has gone come really far over the last 2 years, frankly. We've learned a lot. Fun fact, we've rewritten AutoGen twice, completely different architectures, and I feel like we're still all learning. And a lot of that has, there's also been some standardization around like all we've learned as seen in some of the products we have at Microsoft. So there's Azure Foundry agents, Copilot Studio agents, that sort of thing. So
I have to ask about why you rewrote it twice. So that's coming
yeah,
back up later, I
yeah,
guarantee it.
great.
Karthik, why don't you go ahead?
Yeah, sure. Thanks, Sam. And thank you, for the invite to be on this panel, Raja. So I'm Karthik. I'm currently head of AI at Wand AI. At Wand, we are basically building tools for workforce automation and for workforce autonomy in order to basically support the hybrid workforces of the future, which I think are no longer of the future. I think we're seeing them already with, everybody using agents in their everyday tasks, whether it is coding, whether it is technical support, whether it is sales and go to market. We just had a fantastic demo put on by one of our GTM directors today, where he created essentially an entire app over the weekend, in order to help him with this selling. So yeah, there's a lot of interesting things in that space. Before coming to Wand, I spent some time working on a lot of planning, reasoning, conversation, workflow automation, and so on at IBM. In fact, Victor and I go back a long way. We were part of the same team at
Oh, look
IBM.
at that. That's
Yeah, yeah.
amazing.
So yeah, um, and yeah, and since then, I've also been in the world of startups a little bit. Essentially, during this time of great acceleration in AI, and specifically based on LLMs and the agentic paradigm and so on. It's a great time to be putting in effort in this space. I think there are great payoffs to be had, and there's also a lot of great research to be done, a lot of learning, as Victor says, to be done. So yeah, I'm looking forward to the panel. Very excited about it.
I mean, you can tell already that everybody on this panel has a ton to say, and I'm very excited. We have to start off. I think there was an email thread before this panel about, well, maybe we should start with what actually is an agent first and ground it. And I think that was a very good call out. I think sometimes we in this field just jump immediately to what's cool, what's in the latest research paper, and it does help to ground a lot of these conversations. I often have a little bit of a spicy take on what an actual agent is because I'm hyper focused on tools. But I'm going to say now, Victor, why don't you start us off and give us your definition of what you think an agent is? We can't hear you. You're on mute. You're on mute. You're on mute.
Yeah, so sorry about that. Yeah, gets me every time. So about a year and a half ago, or about a year ago, I started to write a little book around like, hey, no, how do I help people navigate the whole multi-agent space? And at the time, I defined an agent as an entity that can sort of take a task, reason over it, um, is able to act, um, and then can communicate with other agents or humans, let's say get feedback, request handoffs, and then it can adapt So adaptation here means like it can take into consideration the state of the task, maybe previous experience, and then solve the task.
Are handoffs part of the minimal required set of the definition of agents, though?
So handoffs in my original definition, no, but the ability to act here is tools, and most of the time,
Agency.
tools are driven by handoffs. Or I don't know, handoffs drive tools, or handoffs are implemented by tools.
What's a
But
handoff? Define that for people.
Yes, so that was an agent. So the next thing above an agent is a multi-agent system. So essentially, you have a set of independent agents. They have their own configurations. A task comes in, there's some sort of decomposition of the task, say assignment of capabilities or assignment of sub parts of the problem. And the process of flow control between one agent or one entity and another, typically we might think of that as a handoff. And so I guess, Sam, in your context, the process of an agent sort of arriving at the conclusion that like a part of the subproblem is complete, and there are a set of other entities that might be capable of completing the rest of the problem. So the process of constructing that, clear control flow transition, we can think of that as a handoff. So just to reiterate, an agent is an entity that can reason, act via tools, adapt via memory, and then communicate with other agents or human beings. And that's usually a starting point. Over the last few years, it's gotten a bit simpler for me, and as just anything that can address a task on behalf of a human. And I might talk about later why I am arriving at that more simplified version. But if you wanted to be,
I'm already excited.
reason,
I
act,
think
adapt,
key
communicate.
point being act, right? It's
Yeah.
agency. An agent is not an agent unless it has agency. That's kind of the whole point, right? I say this all the time, like, tool runtime, where you run a tool is now an exercise for the developer. It's something that MCP tried to address, right? Is that it's now part of the agent loop to say, oh, I need to go and run this particular deterministic, possibly piece of code on behalf of this agent so that it can act in the real world, right? That is a very important piece that I feel like about a year ago we kind of just left out, you know? More or less, I'll say. Karthik, Hamza, additions, subtractions, thoughts?
Yeah, I think one thing that I think it's a great definition by Victor. I actually want to go back a little bit to, the early days of AI, right? Because again, it may feel to a lot of people like, oh, agents, this new thing that we're talking about. Agents are one of the very first things that, when AI as a field kind of started in the 50s, right? Agents were one of the first things to be defined, right? And every time I hear agents, this is
These are the
actually useful.
50s, like Alan Turing, 1950, computing
Yes,
machinery and
yes.
artificial.
I'm
I
literally
love you
talking about
already. That's
I'm
great.
literally talking about 1956, the Dartmouth workshop, which was where they termed, they kind of the field of artificial intelligence was born, right? And again, agents were one of the first, I guess, in today's parlance, motivating use cases of AI, right? So this is very useful for me. I'm going to put it out there, for other folks as well. Every time I hear agent, I think of this very simplistic picture from the sort of the Bible of AI, right? The Russell and Norvig textbook, the, artificial intelligence, a modern approach, the green book with the Berkeley Campanile on top of it and so on. It's very simple. There is a world, right? You draw a square box. There's a world where things are happening, right? And you have an agent beside that world, right? And there are two arrows, one going from the world to the agent and one going from the agent to the world, right? So the arrow going from the world to the agent is where the agent is observing, right? So there are observations coming in from the world, right? How does the agent do this? Via sensors, right? You have to have sensors so you kind of understand what is going on in the world and get all the information and so on. And similarly, there's another arrow going back from the agent to the world, right? And those are actions, right? How do you act in this world, right? And how do you actually, execute these actions? Effectors, basically, right? So today, when we talk about tools, the tools are nothing but the superset of all of these sensors and, actuators or effectors put together, right? And the agent is nothing but the brain of the agent. It's taking all this information that's coming in from the world, it's processing that information, and then it's deciding what's the best next step to take, right? And I think to me, I always find myself going back to that kind of definition, because that is kind of the simplest definition on which you can layer all of the innovations of today, like tools, like agentic frameworks and so on and so forth. You can add multiple agents into the system, how they interact and so on. In fact, I think there are a few questions in the chat also about how are agents different from microservices, right? They don't have to be, right? But they are in the fact that agents can think for themselves, right? You don't have to write all of the deterministic code, telling the agent what it needs to do. That's where the power of LLMs comes in and so on,
I
right?
thought my definition was simple, and here you are with two entities in the diagram with
Right. No, again, like I said, I find it useful because for me, this is the canonical definition of an agent, right? And everything we add on top of it neatly slots into that, and we kind of build. It's like an onion, right? You have the simplest layer in the middle, and then you build these other layers of complexity on top to help you address the complexity of the use case that you work with and so on. But yeah, that's really where I would go.
There's an interesting kind of comparison to reinforcement learning there, where you're talking about interaction with an environment. I want to come
Mhm.
back to that later, but
Yeah.
that's very interesting. Hamza, anything on that you want to add?
I think I'm going to be the other spectrum of the conversation.
Oh, here we go.
Think of agents as bad interns. Let's just start with that, right? I think so. My job is to help people understand, like explain like I'm five, right? So I start with, okay, what are agents? Think of agents as bad interns. Their job is to go to different people, which we call tools, to get a job done.
Hmm.
And sometimes they forget. Sometimes they hallucinate. Sometimes, you say, first you have to go to the finance department, then you have to go to the marketing department, and then you have to go to the HR department. And what they end up doing is they're going to the HR department first and then to the finance. So, and sometimes they do it the right way. So, reiterating, agents are LLMs with access to many tools. LLMs are what is our bad intern, who has been tasked and been described in a simple prompt or complex prompt to go to a certain tool to get a job done.
I'm
And
over
once
here like covering my mouth, like don't ask a question, stop talking.
right, and then when the job comes back, when the job gets done, it is to move it to the next process, right? And that's how I start describing agents to people, because there are so many complicated definitions of it. I try to simplify it, humanize the experience.
So, okay, wait. Here's another point. All of you have brought up this subtly in what you've defined, which is this trade-off between determinism and non-determinism.
Yes.
Like generality that's introduced, right, on purpose now. If you think about it, we snuffed this out over decades with tests and CI in software. We've tried to eliminate non-determinism purposefully, and now we are purposefully introducing it because of its ability to generalize, right? Which is, the LLM aspect of the program. The tuning knob, if you will, of agents, whether it's like a declarative graph gives you, more determinism. And Hamza, you were describing, right? Go to this department, go to this department, go to this department. And that sounds like a declarative graph. And Victor, you were talking about autogen, right? And how you rewrote it twice. So I want to talk about frameworks, their approaches. If you look at something like OpenAI agents, if you look at something like LangGraph, if you look at something like across the board, there's a lot of different approaches. Autogen, another different approach, right? Or even semantic kernel, another one out of Microsoft. They're all very different. And so I'm curious to get your opinions on what's working, when is it working, why are they using it, and how does it affect that knob, that tuning between determinism and non-determinism?
Can I go first? Sorry.
Go ahead, go ahead. Yeah, yeah, yeah.
Again, I'm sorry, I'm going to set the precedent. I am highly against generalized agents. And one of the things that we literally fight with companies, or you fight with people, is to say, build an agent that does one job, which we call the vertical agents. Focus on getting one job done correct, so that you reduce the points of failures. Because when you have an agent or an LLM is 95%, let's say 95% accurate. If you have 30 points of interaction, you have 30 points of failures. The probability of failures go really, really high.
Mm-hmm.
So my argument, or what I tell people, is in order to make it deterministic, is to reduce the number of things that you expect an agent to do for you, and focus on very highly personalized example or implementation. For example, this was my resume agent. It will only find me resumes. It will not collaborate with something else with finance department and get the budget for it. But this resume agent,
Connected to a higher level agent system, or is it like a specialized agent? I'm playing dumb a little bit, but
yeah,
like,
specialized agent that does, like, there's an HR agency. Within HR agency, we recommend having 5 different agents that do one separate jobs for each one of them. Again, for example, if you have onboarding for an employee, a separate agent should handle that. Similarly, if you have, you need to find the right people for a given job description, you should have a separate agent that does that for you.
I heard this said one time as a grocery store, right? You have somebody checking it out and somebody bagging the groceries. It's like a
Exactly.
separate job, right? And so those are 2 distinct agents. They're working towards the same goal, but
Yeah.
they're 2 distinct agents. Is
And
that
that's
kind
what
of
we'll
what you're
be
talking about?
exactly, because that's what we do with microservices also, right?
Hmm.
We basically expand our architecture, modularize and microservice architecture. That's what we've been doing. So that if something breaks, right, we can fix that exact part rather than building, vibe coding our way through 2,000 lines of code into one function that has every single thing that's ever happened since sliced bread.
I mean, it makes a lot of sense. It's the least, responsibility principle, right? It's
Yeah.
the same principle we've seen. Victor, I do want to come to you and say, please talk a little bit about what you just threw in there with why you rewrote AutoGen twice, because I'm very curious myself. Uh, Building off that and also talking about that handoffs, like the, grocery store example, and
Yeah.
also what Hamza said. Add your point there.
Yeah. So first of all, I want to agree with Hamza. If your business has a specific function that you care about, you don't need a generalist multi-agent system. And most of the time when I give talks, I start out with this big circle with a small circle inside. And the big circle is like all the things that IT teams or software developers need to accomplish. And the small circle is the things where a truly autonomous or generalist kind of system really gets you ahead. Now, for every other thing, the key is to know what is the right tool for the job, right? If you have just one thing, you build a workflow. And so a workflow is pretty much what Hamza described. There's a bunch of steps. Each of the steps might benefit from some type of expertise on LLM. You code that in there. You know the exact solution to the problem. You sort of codify that. And that's your software. Now, why might people be interested in that small bit? So I try to describe that as complex tasks. And so what type of task is more amenable to this sort of generalist, leveraging the reasoning capabilities of an LLM just in time to solve the problem. And so it's things like, does the task touch multiple systems? So things like back office kind of tasks. We have emails. These emails need to be extracted. They might have attachments in arbitrary format. Just the kind of thing where you need to reason through the problem. And up until now, we didn't have ways to build software for systems like that. And many people just don't have problems like that. So it's essentially taking our time to localize that. So the first distinction I want to make is workflows versus truly autonomous kind of generalist systems, and know when to make the choice. And with AutoGen, we sort of started more with the autonomous exploratory kind of thing. And I think that is interesting in its own way, because with that sort of software approach, there are like several high-level benefits. So the first is like you could design one system that does many, many different things. If you have a platform, this is interesting to you. So essentially, you might have heard people talk about the concept of the everything app. And this can be very disruptive and can have a lot of market value. Number two, you save people a lot of time. And so the core idea is like if you truly, going back to Hamza's analogy of an intern who's not excellent,
Bad
but
intern, a
A
bad
bad
intern.
intern, yeah.
a bad intern. Oh, well, I mean, okay, an intern anyway. An intern is still essentially they're this type of person that can do all this sort of back office kind of thing. The work they do might not require a lot of skill, but it takes a lot of time. Also important. And so if you can get a system that can do that, you save a lot of time. And then finally, I think there's a final concept that I feel a lot of people miss out on is the promise of a overall self-improving system. So stick with me here.
Uh-oh.
Yeah, stick with me here. Imagine that you could build this sort of general system, and the performance, you could measure it anyways, let's say 50%. And in about a month, you measured the same system, you made no change, and now the performance is at 80%. So all that has happened is that the underlying models just got better at agentic orchestration, they got better at tool use, they got better at exploring the most efficient path to solving a problem in a generalized manner. And you didn't have to do anything. Like all the folks pouring all that money into the model, they did all that work, but your system just got better. And so those are like three things that make this sort of autonomous approach kind of work well. So I kind of stop there. So workflow versus like multi-agent, automated multi-agent like exploration. We need to know when to use what. Maybe today the workflows work really well. We can measure them well. We can evaluate each tiny component, and maybe that's where we go. But maybe the future would be like, and for a specific class of problems would be the multi-agent space. I really want to hear what Kartik has to say though, because
Yeah, I was about to say, I know Kartik has something to say here. I want to interject really quick and say, like, it sounds like I don't know who's read the Go Explore paper, but they were playing like Atari games essentially. It's an RL paper. And the exploitation versus exploration and how you're talking about this and the trade-offs between them. And again, it's kind of like that tuning knot. There's a really interesting aspect of that I think we could dive deeper into, but I want to give Kartik a chance to talk about it.
Yeah, no, I think what I'll do is I'll maybe give it more of a enterprise POV in some sense, right? So I'm overcompensating for going research heavy in my first answer, right? Um, and building a little bit, I think, on what Hamza and Victor were saying as well, right? So one of the problems that we have noticed, when we take these to clients, especially enterprise clients, right, is, and it kind of breaks down into three things that I'll try to, break it down into. First, and I really should not be saying this, so please don't quote me or record me on this, right? Not everyone needs agents, right? Like, let me just put it out there, right? I know we're all trying to, sell things, we're trying to build companies, we're trying to build these things, but let's also be sort of intellectually honest for a moment, right? There are lots of great tasks today. And again, this is going back to Hamza's point of narrow, agents and so on. Sometimes a narrow agent is a piece of code, it's a script, right?
Yep.
You don't need anything more complicated than that. If
Even
that's been
25 beats RAG a lot of the time.
right, right. And if that's been working for you, then
Yeah.
please resist the FOMO of
Yep.
going to an agentic system, because you are just opening up a world of pain, right? But that's one part. So I'll say that just as on the outset, that I think we're all aware of that, and I think it's important to acknowledge that a little bit, right? The second thing, which is actually something that we've been working on a lot over the last 6 to 8 months, right? And in fact, as part of that is where we've had the pleasure of working with Autogen, with Victor's tool and what his team is building out, but a lot of other frameworks as well, AG2, Llama Index, Crew AI, all of these other things, and we've been building our own internal framework as well. Is when you do have a relatively complex task, right? What you then need to do is, again, agreeing with what Hamza was saying, that I think generalist agents are not the way to go, right? Instead, what you want to do is now split a complicated task into multiple agents, right? Multiple specialized agents. Now, how do you do that split, right? So one of the ways of doing that split is you can have, I guess, what we call internally a project manager agent, right? So this is an agent whose role is basically to take a complex problem and break it down into a multi-agent assignment problem, right? And so as part of the project manager, that's something I think, Sam, that we can also discuss in the panel. What are all the, first of all, you need to do the breakdown. Second, you need to do the assignment to specific agents, right? So which, the role-based assignment to the actual task, right? Third, you need to do the planning task, right? Which is you need to plan out an actual sequence saying that, this goes first, then this goes next, and so on and so forth, right? And then you need to do kind of whatever you want to call it, either the self-criticism or the reflection or the replanning, different terms for everything. Because a lot of these things, again, remember that you're interacting with real world data, and the real world is anything but predictable, right? So you want to have an ability to replan and so on. Okay.
That's
So
a
that's
really interesting point, though, is the real world data. I just want to harp on that really quickly, is that
absolutely, yes,
it totally changes the replanning and the,
exactly. Yep.
readdressing the query step
Yes.
is when you're actually addressing like a user's Google Docs. Obviously, this is something we're running into at arcade.dev, is like we now have the user's data, right? Because we can progressively go get that. And
Correct.
that completely changes the replanning step, being able
Yep.
to access these real world systems.
Yep.
And so that's a very interesting
And
point.
in fact, there's a nuance there which I think is obvious to you, but I think we should mention it, right? Which is all of this real world data is runtime data. It's not data
Yeah.
that you have access to beforehand, right? So you cannot fine tune a model or fine tune an agent with it. You have to react on the fly
Or
in
an
some sense,
embedding
right?
model for a vector database. Like it's not,
Exactly.
you're not fine-tuning that. You're not embedding this all into a vector database. You're going and getting that Google Doc at runtime.
Exactly. And so I'll end with this last thing. So there is this project manager paradigm, but that is still a very interaction heavy paradigm, meaning that you still need to expose the decisions of the project manager to the human in the loop, right? And you need to keep them informed of, here is how I'm breaking down the task, here is how I'm executing it, here is how I'm replanning and so on. Okay. And then now there's a third paradigm, which is increasingly, I think gaining a lot of adoption, which we are also supporting, which is kind of this full autonomy model, right? Which is basically if you have a human who comes in and says, look, I want you to build a department for this particular process, right? I don't care about being informed of all of the nitty gritty of what happens in the department. I just care about the output. I just care about, the end result of things, right?
I've heard this called ambient agents or like background
Right.
agents,
Things that are
things that
running
are
in the
working in
background.
the
Yep. And
background.
producing
Quad
and produce.
code is an example, or like the
Exactly. And
box that Langchain put out.
exactly. And in fact, the perfect example of this, again, like I said, don't quote me to my
It
CEO.
is recorded, by the way. So
I
this
know, I know.
every time you say that, I'm like, oh my God.
I know, I know. I'll make sure that the audience that's not supposed to hear this doesn't hear it. But for example, CEOs are the perfect audience for this, right? Where basically CEOs will come in and say, I want to build this app, go away for 24 hours, don't bug me, right? I'll give you the resources you want, I'll give you all the definition you want, and then come back to me with the output, right? And so that's kind of the third thing where you have a very complex task and you want now an army of agents that are breaking it down for you and producing something that is in line with your expectations, right? So these three things, just to recap very quickly, and then I'll pass it on, right? One, maybe you don't need agents at all. Two, if you do need agents for a complex task, maybe you need something like a project manager where you can use that as an interface, right? And three, maybe you don't actually need, again, any interface. You just have an army of agents going ahead and producing whatever you want. These are the paradigms we're seeing, more or less.
I have so many questions myself. I imagine the audience is now just peppering us with questions, but I can't even see the QA right now. I so many questions, but the one that's on the top of my mind is you kept saying project manager. And I'm curious, in these multi-agent systems, Victor, Hamza, have you experienced that the personification, like the giving it a role aspect or like supervisor role type agent, multi-agent system, has that been effective in like the planning and reasoning steps for a multi-agent system to solve tasks or arbitrary tasks?
In in my um in my experience, we need to have one. We
Yeah.
absolutely have to have an independent one, unequivocally,
What does it do? What does it do? I mean,
it
I'm
just
playing dumb again, but like,
it just do LLM as a judge. So for
doesn't
instance,
that compound errors though?
yes and no, because what you do is that if you have a compound error, so let's say it hallucinates. So what is an agent? Your LLM is given a JSON output for you, right? The JSON output is basically a tool that you will call to, right? What we're trying to do is that the act reason the action that you have to take, the reason that you're taking that action, right, and the some instruction that you need to pass to that tool. Those are these three outputs that we expect from an LLM, right?
Hmm.
That is the first part. The tool activates, the tool gives you back a result. The AutoGen team, Victor, I'm going to say this, have done such a great job in having LLM as a judge, because it works independently and it has a prompt that says your job is to see if this is done correctly.
What does that prompt look like for the audience? Like I've written a few of them, but like
Yeah.
what are the key components of an LLM as a judge prompt for that kind of reasoning?
You are an LLM judge. You will be provided with output from tools A, B, C, D, E, F, G.
Yep.
This is the expected outcome. Please provide with a yes or no or a reason in JSON format. Please provide it in JSON format.
Please, JSON.
I think 4.0 has become pretty good in that. But please provide us the feedback in this loop so that we can evaluate. So if you're generating an image of a dog standing standing on Mars, right? We need that image to be generated correctly. But real human interaction. A lot of companies are implementing voice AI for taking orders. IHOP is implementing, right? If you say, hey, I want 16,000 pancakes, the LLM as a judge, or I mean, eventually we'll have human in the loop also, but the
There's got to
LLM,
be a human at some point that goes, that's not a real order.
yeah, yeah. What we do in data science agents is that we look at an output that has been generated from a forecasting model, and we say, does this sound right to you?
That
And
makes sense.
sorry, go ahead.
Oh, it makes sense. It is the counterpart. I think the interesting part to me is like when you involve tool use is something that I've obviously, dove, headfirst into, is that it changes the LLM as a judge step because the data you can get back is very diverse.
Yeah.
And so it's not as simple as you're judging what the LLM is output. It is not a LLM generated piece of text necessarily. It could be a large, large quantity of, documents from Google, or it could be, your Confluence or Jira or what have you. And all of it, I mean, you think about it, there could be a prompt inside of one of those documents, right? And so this has been a really interesting challenge as we've connected to more and more systems. I'm curious, talking about tool use in general, with this reasoning and planning, has there been any challenges like that that you've seen with tool use or any tools in general as things like MCP have come about, that you've seen in particular that are interesting and noteworthy for the audience? Anybody? Anybody? Grab the baton.
Yeah, so I think one thing I will say there is um, there's a lot of not existing, let me say, there's a lot of pre LLM theory and applications, right? Especially from the field of, again, this is a plug because this is the field that I come from, planning and reasoning and sequential decision making, right? There is a very rich history of work over there that basically deals with exactly these problems, right? Which is, how do you create a plan? How do you, replan effectively? How do you create kind of these structures so that your overall execution is going to follow a particular guaranteed path in some sense, right? The thing that's new now is we are replacing the more or less deterministic insides of the brains of these agents, right? Now with something that is quote unquote non-deterministic, right? I say quote unquote because ultimately it is also running off of a probability distribution and all of that. It's not really non-deterministic, right? We just don't have the compute and the scale to make it deterministic in some sense, right? And in fact, that is the reason that we use LLMs as the basis for a lot of these agentic systems,
I
right?
appreciate
But
you for explaining it like that.
but in my opinion, there are two ways to go about this, right? One is we can actually we can reuse some of the more deterministic structures, borrow from planning and reasoning and scheduling and sequential decision making, right? I'll post a couple of examples of papers, that did this, in the pre-LLM era. And we can kind of constrain whether it's MCP, whether it's A2A, whatever. That's more of the implementation of the tooling stack and all of that, right? But you can kind of think of it almost as today everybody knows about the concept of guardrails, right? But in the concept of something like RAG, right? So the guardrails are ensuring that the content, the text content that your model is putting out or that your RAG chain is putting out is conformant to a specific set of constraints or whatever, right? So I want us to think almost of guardrails, but for reasoning, for agentic chains in some sense, right? So what we're essentially saying then is, yes, I know that there will be uncertainty in the output, but I will quantify that uncertainty. And I will say that, okay, whatever plan this multi-agent system comes up with will be within this particular, execution, will be within this
How
particular
do you
trace.
do UQ like uncertainty quantification in this way with such a unfathomably large space of possible outputs?
Correct. Correct. So I think that goes back to the point Hamza was also making about kind of this error propagation, and the more complexity you add on, the more unchecked error gets propagated and so on. I think the way to do that again is to kind of isolate agents and tools into these, so if you think of a plan and you say that each plan has a slot for an agent or a slot for a tool, right? And then you kind of wrap that around with these, like I said, the reasoning guardrails in some sense, right? Saying that this agent's outputs can be within this distribution, but not outside of it, right? And if it falls outside of this distribution, then we kind of replan essentially, right? That's
Oh,
really how I would
we have
quantify.
5 minutes left, unfortunately.
Yeah.
I just realized sorry to cut you off. We have not done any question and answer. We went way too long. This was a fantastic discussion, though. Um, let's do a quick Q&A. We can do a few of them. There are 83 questions, 84, 85. Wow. Um, all right. Anybody have a particular one that they're interested in? Because we are not going to get to these. I would appreciate it if anybody stuck around and tried to answer these with me. Um, whew, uh, let's do. Mm, 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 mm.
So Sam, I have been looking at the questions. I mean, do you need any help
Yeah, that would be
answering
wonderful,
those?
Raja. I have not looked at any of
Okay.
these.
So I think one of the consistent themes here that I asked, and I think rightly so, one of the questions that people are asking is, well, how is an agent different from agentic AI? And does agentic AI still use Gen AI and AI or not, right? So I think that's probably something in that realm. And then one more thing, somewhat similar, how is it different from RPA? So I think that's a few different questions.
I'll touch
I'm
on
putting them together.
this latter half. RPA essentially has no, or it should not essentially have any non-deterministic element to it. There should not be an uncertain piece of that program. When you call, process automation, when you call that process, it should run that process if it's a good RPA system. In this case, you are having a large language model control when and where that process is called and which process to call. And so that is an uncertain process that's actually saying which one to call, and actually how that process is called is also controlled by the LLM. So that would be the difference. The first part, I would say anybody jump in on.
So I think I'll take a very quick shot on that. We want to think them as complementary, not as opposed to or replacement of each other. So the way we're built, and maybe it's just one way of building it, right? 5 + 4 is 9, 6 + 3 is 9, 10 - 1 is also 9. So
I
the
love that.
idea we try to drive is we use an agent to call an agentic RAG. So our agentic RAG is built on the architecture that, there's a question that comes and it, sort of comes up with its own idea of how to approach and find the answer. The agent's responsibility is to call the agentic RAG tool. So this is my definition of, separating the two entities.
Hmm.
If the agentic RAG fails, it's on the agentic RAG and we need to fix that. But they're not compounded in a way with each other. They're not fused in with each other. They're just in two independent entities. And we have seen the maximum benefit come out of it because I can make my agentic RAG really complex. I can build my routers. I can build my semantic search and, all sorts of interesting things within that. I could do query expansion.
Intent.
That intent, right? Hide, we use hide. So all of those things are set within the agentic RAG. Who's providing an answer to an agent and says, hey, can you tell me what is the difference between the revenues of Uber and Lyft across the past 2 years? That's a complicated question. The agentic RAG's job is to break it down into atomic units and then find the answer for you and then return back the whole answer rather than the agent saying, oh my God, I have to do every single thing myself and then break it down and go and fetch the answer.
I'm laughing also because I've seen a lot of people abstract tools up towards the agent. So like that question becomes not as difficult if you have a tool named like get stock summary for, X company, right? And the arguments are something string based that are easy to, discern for an LLM. And so like as we've seen people build more and more intelligent tools, the like going up after MCP a little bit, the agent's job has been reduced in its like let's say complexity and responsibility to some degree to the point where it's more like what you're saying, which is I need to just delegate, right, into a new group that is specifically purpose driven towards this goal, which is kind of in line with what you said earlier. The vertical specific do your job kind of agents.
It's an interesting, I'm sorry, taking more time. It's interesting that demo are everywhere. Everybody shows a demo, at least in
Get
data
whether
science, in the previous world, in our previous lives of being a data Kartik, I think you were too a data scientist or somehow. We used to have accuracy, we used to have F1, we used to
R
have
squared.
instant recall, hard-coded benchmarking on how good my model is. Now we say, hey,
Looks
I
good.
I, I scripted out, I OCR'd a 10K document, one page, it's gonna work now, give me $10 million. I call BS to that. I just basically say, you know what? The real world and the demo world are completely different.
Absolutely. Absolutely. One of the first things I focused on was evals for tool calling and trying to make sure that in my CI every night I could tell what the model changes did to my tool calling system. Because, back then they didn't have dates on the models like they do now, right? They just released a new, GPT 3.5 Turbo. and it would completely change the tool calling system.
Yep.
Now they luckily at least have dates. Let's do one more. We have probably a little bit of time.
So
I
I see an interesting question. How do you
uh,
handle error recovery and
what was
error
it?
handling and recovery in multi-agent systems that
Ooh,
work asynchronously?
that is a very good
Um,
question.
yeah, so so there's several ways to do that. It depends on how you architect your system. So if you're in the workflow domain where as a developer, you already know the solution to the problem and you've expressed that as a bunch of steps in your pipeline, it's a bit easier to do that because you can essentially unit test every single component. You can get a good sense of where things are failing. You can benchmark that at scale. Ideally, everyone should have eval-driven development where you have a dashboard and you can see how things are going. So that's a good way to think about it. Don't abandon any of the software engineering principles we've built out so far. So eval-driven
Yes,
development,
Victor.
unit testing as much as your stuff. Create a dashboard, and sometimes you should start out with a baseline that might not be agentic, script, like Kartik said, and then you have a version that is increasingly more complex, and then you can go back to your investors and say like the reason why we have this complex version is because it objectively does better than the initial version. So that's really where you should start out with. Because we have LLMs and agents, it means nothing. Doesn't mean we abandon everything we know about how we build software systems. So
Nobody
that's
wants to create that first version, though. They all
yeah.
want to jump to the second version, but
And
you're right.
it's
It's exactly what
inescapable.
they need.
It's inescapable. You really should not think you can make any kind of meaningful progress without building your evaluation stack. You can't. You can't. You just can't.
I've never
Anybody
seen
who's
an
telling you
agent pod
differently,
without handwritten evals.
yeah. Anybody who's telling you
Never seen it.
differently, should talk to Hamza. So that's the
Incredible.
first thing. The second thing is if we're in the multi-agent domain, and I always talk about the fact that I'm a researcher and I spend a lot of my time thinking about what the future of these systems could look like. So today, autonomous multi-agent systems still have a lot of issues, error propagation, error accumulation, all that. I feel all those things will get solved. They're just not the way to do it today. But if you're going to implement a multi-agent system today, if you looked at a paper we released sometime last year, a paper called Magentic 1, which was a multi-agent configuration where, a complex task comes in, there's actually a module that does like explicit planning. It says, okay, here's the problem. We're going to break it down to a set of steps. We're going to assign each of these steps to one of several agents. And as each agent takes an action, this planner is going to review, do some sort of metacognition, like, are we making progress? There's a ledger, a structured ledger, an actual JSON data structure that it updates. So it has things like educated guesses. It has things as the state of progress. Are we stalled? It has a stall counter. Like, have we failed to make progress across n number of tries? And you need to do this because if that is the case, essentially you're taking actions in the real world. What you expect is that it leads to, progress in the problem solving process. Sometimes it doesn't, and you need to keep track of that. And at that point, the solution might be to sort of reset the state of the entire problem, construct a completely new different problem exploration trajectory, and then explore that again. And at some point, you decide that we really are not making progress and we need to escalate to a user, or we sort of give up at that point. So you need some actual sort of logic that guides, even though you still have an LLM exploring the space, but you do need some type of metacognition logic that ties or drives together all of these. And I'll sort of end a bit on just revisiting some of Kartik's earlier points about like how we can put some structure around the reasoning process of an agentic system. I think the one drawback there is that you really need to know the solution to the problem really, really deeply to construct that space. And so if you want to put the guardrails around what the system can do, you essentially need to solve the problem to understand the problem real depth. So there's a bit of a trade-off there. So we're also learning about this space. Or maybe Kartik has figured out a way to do this in a generalized form, and he should tell us.
I would like to say that, I have figured it all out, years back. It's just the implementation that's a problem. The agent has figured it out. It's the tooling that's not ready yet. No, I think I will, say that a lot of this theory, I think I saw a question in the chat about, do symbolic AI methods have any role to play in this, right? And I will be kind of the flag bearer of symbolic AI, even if nobody wants to be, right? If you are someone new to this space, right, and you are looking to really make a difference and stand out, right, there is a lot I think we can learn from previous symbolic AI techniques, right? Obviously, sequential decision making, automated planning, but also things like scheduling, replanning. There's a lot of work on human AI interaction, both within the AI community, but also within the HCI community, the human computer interaction community, right? Because I feel like in the coming, I would say years and decades, but we are not operating on those timescales anymore. So I'll say in the coming days and weeks, maybe months,
Literally,
right?
like
Um,
literally.
yeah, yeah. I feel like a lot of the human factor issues, which to be very honest, we've all not paid a lot of attention to in this mad rush to, build LLM models, build RAG chains, build agentic AI, frameworks and all of that. I think a lot of the human factors issues are going to become very important because we are still in a world where humans want interaction with and oversight of the agentic chains that we build out for them, right? And if I were telling somebody, where to position themselves for the coming weeks and months, right, I would really tell them to focus on how the interaction with these agentic outputs happens, right? Because today that is still not a solved problem. That is in fact the biggest, the rubber meets the road moment, right? We all went through a big revolution like this for RAG, if you remember, right? So for retrieval augmented generation, right? For the longest time, it was very hard to implement that in practice in reality to show organizations that they were getting value out of it, right? Today, we are in that same place with agents and with agentic frameworks and all of that, right? How do you show a paying customer, right? That this, because there was also, I think, some questions about the cost of running these agentic frameworks and multi-agent systems. It's not a non-trivial cost. It costs a lot in token budget, in compute, all of that, in developer time and so on. So how do you realize that value and make it real for your customers? I feel like there's a lot of unexplored work there. And that's where I think symbolic AI techniques from the last 10, 20 years, HCI techniques, I think those will become very useful over there.
I'll add to that accessibility, which I think is super important. The HCI world is like the pioneer, if you will, of accessibility, and LLMs have a huge part to play in the world of accessibility, and more people should go into that field so that we create a more diverse field for ourselves. That I'll add. Lastly, I 2 points Victor and Kartik that both pointed out. You said reset the environment, Victor, like reset back to the beginning stages. What we're finding in tool use is there's a lot of cases like if you book, delta.com, you can't just kind of go back a lot of the
Yeah.
times. Now you
Yeah.
you can if you specifically
Yeah.
have a tool to do so, right?
Yeah.
But
Yeah.
thinking through each of those stages, which kind of gets to the Kartik point of like, are you sure you want to buy this flight? Because
Yeah.
especially with the OAuth primitives that we have now, we have the full set of agent user privileges. And so this agent is now empowered to do real things. And so it is important that you have a kind of like a rollback strategy, if you
Yep.
will. That is something that we're actively working on. It's a super curious area that kind of merged two of what y'all had said. Hamza, do you have any final thoughts that we have before we wrap up here?
I just want to say Black Mirror is becoming more real each day.
Oh my God, don't say that. That's that the one with the episodic recall where he
Yeah.
had that is the creepiest episode I've oh my God.
I think
Oh,
I'm just going to say something what Karthik said. You don't need an AI agent for every single problem. You don't. And I think the quicker we understand that, see, how are we building stuff? Or 2 years ago or a year ago, how we were building stuff, we would do a hackathon in an organization, and all the developers would sort of build something. That's the wrong way of approaching. You need to have the business owner sitting, having a design session, and saying, hey, what is it that we want to solve? And the developers and the tech people will help you understand how AI can solve those problems for you. We've been doing the other way around.
hammer looking for a nail.
Right, exactly. So we just need to identify, and this is something that we do a lot with our customers, the design sessions, like, what can Gen AI do for you really?
It's like, what are your problems work backwards?
Exactly. And is this something that you need? Do you need just a forecasting model, which will wrap it up in a fancy LLM and sell it to you as an AI agent? But the idea is,
We'll have it talk to you. It's just an XGBoost model in front of a wrapper, but it's just XGBoost with an LLM in front of it. I love that.
I love XGBoost and LGBM models.
Hey, nothing will ever beat XGBoost. I'm convinced it's going to die the best classical model of all time. Probably not true, but still, it's undefeated on Kaggle. So, I think we're getting kicked off. I just want to say thank you all, and feel free to connect with each of us. I'm at Samparty on Twitter. If you have any of these questions, which there are 146, so please feel free to DM at least me, and I'm sure some of the other candidates are also okay with that as well. And look forward to the follow-ups. Thank you guys so much. This was awesome, and I feel like I even learned something. So really appreciate y'all. Thanks, Raja.
Thank you.
Thank you,
for
Sam.
having
Thanks,
us.
everyone.
Thank you.
And-
Thank you, everyone.
Yeah.
Bye.
Thank you. So we are going to take a quick break. Our next session starts at 10 a.m. Pacific time. I'm going to go ahead and just display that's the schedule for the rest of the day here on the screen, and then we'll be back at 10:10. Thank you. Hi, Mazuma, how are you? We are on a break. We have another 3 minutes, but we can get started. I saw Chris and Aparna on the screen. Hey, Chris.
Yeah, I also see Vikram and Vibe over here as well. Hi, everyone.
Hey,
Hello, pleasure to join you.
but here it is.
Hey,
Okay.
everyone.
Can you hear me?
everyone. Yes, we can.
Wonderful.
So we have maybe another minute or two. We can, and if you want to get started, I mean, feel free to go ahead and get started. The next session is starting at 10 a.m. So we are right on time.
Yeah, maybe we can take like 2 minutes to just walk through the flow. I have sent to all of you the flow. I've seen some comments and stuff and updates, so I think it's all good. Yeah, we'll just start with intros, 1 minute intros, and then we'll get into questions, 4 themes. And I see the Q&A and everything on my screen as well. So if there are questions from the audience, we'll definitely take them. I also have some backup questions in case we don't have a active audience. And looking forward to a great discussion. This is a great set of folks.
Thanks for having us, by the way.
Yeah, thanks, Masima.
I didn't do anything. That's all Raja and his team. I'm just
All right, never mind.
Thanks
We
all
take
of you,
all of that
actually.
back and it goes straight to Raja.
Yeah, thanks all.
Whoever deserves the thanks, we appreciate it.
All of us,
I appreciate the
actually.
opportunity to be here.
Yeah.
Okay, it's 10:09, so
So I think maybe Mazuma, I mean, I will disappear and I will let you take over from here. Okay.
sounds good.
Yeah.
I didn't know Zoom lets you configure the background of every attendee by default.
I think it's a feature, so I believe we are live. Let me know if you're not. Hi, everyone. Thank you for joining. My name is Mazama. I'm here for our next panel. The topic for this panel is designing trustworthy agents, observability, guardrails, and evaluation agentic systems. I have a set of esteemed panelists here. We'll probably go into a quick round of introductions, starting with you, Aparna.
Awesome. Well, hey everyone, my name is Aparna. I'm one of the founders and chief product officer of Arise AI. Arise is focused on LLM and agent evaluation. We focus on making sure that teams have all the tooling from development to production to building successful agents in AI applications. We really think of ourselves as kind of that unified place where you can develop, iterate, evaluate, and then ultimately when that application goes into production, you have all of the tooling to be able to make sure it's successful. And part of the stuff that I think we'll go into today is, everything about how do you debug agent trajectories to how do you write complex evals. And a little bit about me. Come from a technical background. Prior to this, was at Uber for many years and was an engineer. So yeah, excited to be on this panel with you all today.
Thank you, Aparna. Vikram, you want to go next?
Sure thing. Thank you again for having us. I'm Vikram Chatterjee. I'm the co-founder and CEO at Galileo. We're the leading AI reliability platform, specifically focused on working with enterprise AI teams on all things, again, like from offline evaluations to real-time monitoring to real-time guardrailing powered by our own Luna evaluation models, which we built out from scratch. About me, I was heading up product management before this at Google AI, specifically working with the Transformers team and working with language models, therefore, for the past 6 to 8 years. Super excited about this conversation, especially as we enter the world of agents and how these systems are getting even more complex than they ever have been. So it's fun times.
Thank you, Vikram. Chris, do you want to go next?
Sure. So Chris joined. Very happy to be here. I am the director of product marketing for our AI security products at Security AI. So I'm coming at things really more from the data security angle, right? How do you, in an agentic world, how do you keep your data, protected when you may have sensitive data? You have to be careful, of which agents can use which data for which purposes. And as we give agents access to tools, right, and kind of start to look at ecosystems of multiple agents in an ecosystem, how do we keep that locked down from a data security perspective, right? So that's kind of the angle that we're coming at things from, less from the model controls and what's happening inside the model, and more from the environment and the data security. So I live just outside Philadelphia. I've been in data and analytics and AI for my entire career thus far in various roles. But I'm happy to be here talking with you today. Thanks for having me.
Thank you, Chris. And last but not least, Vaibhav, do you want to go next?
Yeah. Hey, everyone. I'm Vaibhav, one of the co-creators of BAML, and then which is funded by the company Boundary. We did something incredibly silly. We made a programming language, which is probably very different than a lot of other people. But we think really agents, people are tossing around a lot of new words like memory, MCP, and all these words that describe behaviors that we've had for years. And we think all of it is just functions. You have inputs and outputs, and we know how to build systems around functions, even unreliable functions. Those are flaky functions. And our theory is, in order to build really reliable agents, what you need is something that really helped transform web development in the past, where we went from raw HTML strings to React. So in the world of agents, we probably don't want to use F strings to encode business logic in some ways, and we probably want more than Python to go support it. And our language kind of plugs right in. We have built agents for over 800 companies using our language, all the way from government agencies to tiny high schoolers, building small things out. And hopefully the iteration loop is, hopefully throughout this conversation, one of the things that I hope people understand is that the iteration loop is key to building really trustworthy agents along the way.
Sounds great. I'm really intrigued and looking forward to learn more about that. Quick intro about me. I am a group product manager in Microsoft Azure Data. I lead the database and AI strategy for the SQL business. And really seeing customer firsthand deploying these agentic systems and coming across all these things that we are going to talk about today, starting from observability to guardrails to the trustworthiness of this. And as I've just mentioned about these operations and how you input data, output some results and things like that, and agentic operations at scale. So really looking forward to learn something new from this panel as well. So I thought the way I would go around is we'll divide this into like 3 or 4 themes. The first and foremost, the first theme that comes across with customers that I get to talk to and companies who are building these systems is around observability. And to me, what that means is in an agentic system, how do you really build an observability system? We know in software engineering, where many companies, many decades of experience people have. But in the world of LLMs, in the world of agentic systems, what does it mean? So I'll start with you, Aparna, if you can provide some guidance, or as Arise focuses on the AI observability, how do those principles adapt to agent-based workflows? And how is that different in terms of root cause analysis from agentic systems when it comes to models? So I'll start with you if you want to kick us off with that question.
Yeah, it's a great theme to get started on. So maybe I can start with something that I think has been a pretty big change in the ecosystem in the last couple of years. I mean, 2 years ago, people were building like custom, really like small models to tackle their use cases. And today, the world has moved to using foundational models for a lot of their applications. And I mean, we were talking, I mean, I think Satya Nadella actually talked about this at Build last week, where he was saying, as a product builder, how much do you put into the model and how much do you actually try to build as part of the agent? And so there's some camp of people that are call it model maximalists, where they try to ask the model to do as much as they can. And then there's maybe some that are call it more of like the product maximalists. I don't know. The name for that is probably up for us to debate. And I think the question comes down to, well, you try to shove as much as you possibly can into the model, but you start to realize that the more and more you shove into the prompt, it starts to tackle some scenarios uh, less correctly than other scenarios. And so you start to give some more structure. And that's where some of these agents, you're starting to see a lot of frameworks around these agents like Crew AI and LangGraph, where they have different themes. Some are more of that orchestration worker type theme, where you have a single agent going out to that kind of orchestrates some operation, and you have workers who actually do individual tasks. You have some that are are a little bit more of they work cohesively together like a crew to complete some sort of task. And so I think fundamentally the way as a product builder these days to think about this is, if you're building with agents, there's typically 3 or 4 main things to think about. There's tools that the agents has, there's memory or state that the agent has to think about, and then there's when do you decide to do handoffs between different agents. All of these end up being things that need to be tracked and need to be these are areas where if you don't have the correct memory or state stored, the agent's not going to know what it's historically done in order to be able to take the next action. So that's a very important area to be able to track as part of observability. If it doesn't know what tools to call, or it doesn't call the tools correctly, we see this a lot where the arguments into the tool aren't passed correctly, so it doesn't call it. And so those ends up becoming a failure point for the agents. And then if it doesn't know exactly when to do the right handoffs between other agents in its application, that ends up becoming a spot for a weak spot as well. And so fundamentally, I think the big difference between the old world and new world has really just been, you are building a you're not just worried about kind of the building of the model. You're using a foundational model and you're actually leveraging agents to actually successfully call that model in the right way to complete an action. And thinking about what the agent has access to, what the agent um, needs to think about in its operations is important. Some of the best ways that we recommend for teams to think about this is to actually trace their application. So actively tracing end to end all of the actions that the agent actually took in order to be able to pinpoint where the bottlenecks are in the application are really important. And that's a pretty big difference compared to kind of the world of just building traditional models.
No, thanks for that answer. It's really relevant to what I'm seeing in the customers asking these questions and really about tracing. And I also like your analogy in the beginning around the model versus product maximalization. So it's something we can double click on later as well. So in the same topic, I would like to ask Vikram you from a Galileo's perspective. Working with kind of unstructured data and model quality, going back to what Aparna also mentioned, how do you actually apply the observability when agents make decisions that are beyond the traditional one, like classification and ML stuff that we used to be? Now, the deterministic nature of these models is very different. It's very probability based, right? So, how does that work? And then, if you can double click on something like tool use and memory and all these concepts that we are hearing this conference and this year a lot, how does that work? And how does the work that you have done plays a role there?
Sure. Yeah, and I feel like these terms are going to come and go, and by the end of the year, we'll be talking about very different terms as well. But if you kind of zoom out and look at the forest from the trees, right? What's really changed in the world of computing over the last year, even in 2025, even is if you even compare this to traditional BERT models where we were 5 years ago, these large language models essentially at this point can be considered to be these operating systems, and we're collectively, as a result of that, going through this computing shift altogether, right? So that's the overall macro that's going on. And whenever these computing shifts happen, there's this theory of the phase one and phase two, which is like if you look at the internet way back, right? The phase one was everyone was building these static read-only websites, and recipe websites were the number one unlock, and everyone thought that's it. That was all the internet was all about. But phase two for the internet was the big unlock was when it became transactional, right? When you started to actually buy, sell, and take actions on top of the network, which is already built in phase one. So I think of it similarly when you look at generative AI now. What's happening is last year, I feel like was phase one where we had this proliferation of chatbots everywhere, where RAG-based systems came in and folks were just building different chatbots for payer systems, provider systems, banking systems, all sorts of stuff. And that was the extent of our imagination versus right now, what's actually I feel like happening is we're entering that phase two, where these operating systems powered by these language models are actually becoming more transactional, actionable, more geared towards outcomes versus just generated responses. And so we've quickly gone from LLM-based simple like input-output systems towards these multi-model-based software applications with, to your point, right? Like planners, critiques, handoffs, memory, retrievers, etc. And these are all different kinds of spans. Like Hotel has to up-level itself. Like everything that we've known so far in traditional SDLC has to up-level itself to kind of map to these new span types and these new kinds of modes and objects that we have to now start to look into more closely. And all of these pieces have to work collaboratively towards specific outcomes. And so increasingly, these are very complex compound systems that traditional software developers are just not used to. First of all, because they're more complex, and second of all, because they are probabilistic. And that's kind of where, when we think about observability, that the definition of that as well, in my opinion, needs to change, where it has to shift from traditional, test coverage and looking at latency, etc., towards actually requiring high quality evals. The definition of evals is also going to keep changing over time. High quality guardrails, but those guardrails have to be adaptive in nature to your specific use case. That's an algorithmic research that's going on and in the world of research today. And then also the third piece is feedback loops, because in the world of machine learning, compared to traditional software, it's all about looking at the out of distribution data and then completing the loop with these feedback loops. So I think when I think of observability now with the world of agents, it's more about the combination of these three things. Like how do you build the right kinds of tests? Sure. But also how do you create the right kind of high quality metrics and high quality guardrails which can adapt, and also then close the loop as quickly as possible, so that you're not caught unawares in production. So it's a more complex topic, and we can break down all these three pieces into smaller parts.
No, it's actually going into my next theme, which is around guardrails and alignment. So thanks for kind of putting this out. And then I really like what you said about the definition of itself. How we look at observability is going to change and is changing right now as we are building these agentic systems. So my next question is for you, Vaibhav. If you want to discuss a little bit about the safe deployment of LLMs and how do you kind of enforce these boundaries, as Vikram was just mentioning, when it comes to thinking about useful exploration of these systems. And can you share any specific techniques any of the work that you've done from your perspective where it helps these people who are building these agentic systems?
Yeah, that's a great question. I think when I think about sending data between models, people think of these as the first time that people are experiencing black box APIs. But in reality, as a developer, we've been using black box APIs forever. Every API you call is a black box API. You have no idea how it's going to work. You have no guarantees on what it is, and you just build around it. When Among Us first came up and they built on top of AWS, they built no system to deal with the flakiness of their game system of when things go down. And their game went down all the time. Then what they did was they just added more software, like we have for the last 30 years around that. And now they had small little UIs to tell you that their network was down. And then they added more software to make their network scale up possibly. Because in the end, dealing with black boxes is well established. We know how to go do that. And most people don't have to reinvent the wheel. And I think when we say things like the right tool isn't picked, it actually makes it harder to think about. If instead we think about tool calling as just, what is a tool call? The LLM spits out a structured object that I then pass into a function. And really what the LLM is doing in that scenario is I'm giving it some input parameters, doesn't matter what it is. Maybe it's a chat history, which is just an array of messages. And then it spits out one of 15 tool calls. Well, one of 15 tool calls is a type system that we all know, which is it's a union of 15 data models. And the LLM returns one of 15 unions. And then we have an if statement that says, based on which union it is, we just call the function and expand its parameters. And if we use a type system to build these models out, where we just say, this is just a function that takes in an array of a class and spits out one of 15 unions, we all know how to use that function. We don't have to reinvent observability. We can use the tools that we already know and love. We don't have to rethink about it because the prompt itself kind of matters. But what really matters is, did it spit out the right data model? That is the part that I really care about. Whether the LLM did reasoning, whether it did anything else is an implementation detail. Whether I even use an LLM itself is an implementation detail. What really matters is I have a function signature that has a class of an array going in, and it spits out a union, one of the unions. Did it pick the right union? That is what I want to observe. And that's how we generally help people think about it, which is if we apply the principles of software engineering, instead of like thinking of it, what is memory? Memory is just another parameter that goes into my function of whatever type I want. It could be a string, it could be a string array, it can be a class called memory. It doesn't matter. And I think that's how we generally think about it. And then if you can use type systems to go do this, then you move from the JavaScript world into the TypeScript world. And that is how you build really good apps. JavaScript doesn't build long scalable systems. I think the VS Code team was one of the first teams to use TypeScript ever. And what they have said many times over is they could have never built VS Code without TypeScript. Because you want to find errors at compile time. And you want to build expectations for the developer earlier in like your code without even having to run it. And that's, I think, the same principles that agentic systems need. No matter if you're in Python, TypeScript, Go, Rust, Java, anything else, you really want to use the type system to your advantage. And tool calling is just an implementation detail.
Yeah, well, thanks, Vaibhav. I really like the way you kind of almost like a software engineer kind of break down this problem into like what it needs to be. And I also like the comment that you made about the models, the data model that is the main thing that you need to think about, right? So on that note, related to it, Chris, I have a question. I see in the audience questions as well. So folks, please put your questions in the Q&A section. We have time at the end of this panel to take a couple of questions, and as they're relevant to the current discussion, I will pick few as well. There is a question around governance, right? And then I know that you mentioned in your introduction as well around privacy and governance around this, right? So from that lens, how do you ensure agents don't leak sensitive data or violate any of the compliance requirements that these companies and these customers have?
Yeah, perfect question. Thank you. As Aparna said before, right? We're sort of pursuing this like model maximalist goal, right? And I think Vikram had referred to these LLMs as an operating system, right? That's really kind of what they are now. And the industry has been relentlessly pursuing like these general capabilities, and these things are really, really powerful and really strong. And then we kind of turn around and we're shocked when they do something unanticipated that we didn't explicitly plan for. And it's like, well, okay, I mean, they have general capabilities. And when we're giving agents access to tools and access to data, you know, that creates a significant risk, right? So we kind of look at things a little bit differently, as opposed to kind of let's take, you know, really powerful general capabilities, and then let's kind of assume, you know, we'll give agents access to things that they might need, right? To whatever they might need. And then kind of after the fact, well, let's make a no list of things that we know that they shouldn't do, and try to patrol that, especially as sort of the art of jailbreaking just continues to evolve, right? And continues these to come up with more creative and deceptive ways of tricking models into getting around any of these parameters, right? So instead of that kind of approach, right, what if we start first with the data, right? Let's look at the data. Let's make sure, A, that we have visibility into all of the relationships between data, models, tools, applications, users, right? And we can map out all those interactions, and apply that to, and see where policy is being applied from a data governance perspective, right? So start there with that visibility. Clean up anything that we might have, you know, kind of, not everybody has their house in order all the time when it comes to basic data governance, right? And access controls. You know, so clean up those permissions, and then we can start to look at, okay, how do we put real-time controls into place, right? So that we can see what users or what agents are actually trying to access what things. OWASP actually recommends going so far as to revoke permissions from agents as soon as they're done, right? So when a task comes in, we're looking at it in kind of a context-dependent way and saying, okay, I will approve these permissions, right? And then as soon as that task is complete, revoking those permissions, right? Then what you would have there is you would have sort of a repository, or if you will, or an audit trail of permissions that were granted for agents, that you could review, to stay safe over time, right? So those are just kind of some things I think that are relevant as far as protecting data, you know, in an agentic world.
No, thank you. And I live in the database world, and data is the most crucial asset when it comes to these agentic systems. And this is the number one concern I hear from customers. Anytime I'm starting a workshop, I ask everyone to raise their hand. How many of you are skeptic about AI? Almost when I started, it was everyone. Now it's 50% or less than 40% folks. And then I ask, what is their number one concern? This is always about data privacy and agents and these systems, LLMs, getting access to privacy data. So really like what you
Right.
said about even going to the extent of revoking access when you're done, and then having a good audit trail around what these agents have access to, and how do you dynamically give this access to agentic systems, and make sure that you have a way of doing kind of data lineage in a traditional world and in world of agents as well. So thanks for that answer. So my next is actually the theme is really the third theme here I wanted to discuss was around metrics and evaluations. And I know that Vikram, you mentioned that earlier, and I see 2 or 3 questions already on that. So let's like double click on that. So I'll start with you, Vikram, because you already brought this up in terms of the evals and the tooling around that. How do you kind of, what type of metrics top of mind, if you can mention some specifics around that, that test really the reasoning or the multi-step task success? That's one thing with this complex agent system. It's getting complex more and more. And then Aparna, if you, because you're also in the same space, you mentioned evals and like how you're building some tooling around that. If you can add more context around the tooling, memory, and the API aspect of the same question, I would like to get both of your opinion on this one.
Yeah, for sure. I can get started on that. So, I mean, we've always maintained for the past 4 years that, you know, when it comes to unstructured data AI, especially using these language models in the loop, the biggest problem right now is a measurement problem. And truly, that's at the core of keeping these AI applications from being reliable. And the other piece that we've always maintained when we talk to developers everywhere is that there are no silver bullet metrics anymore, right? Like traditional software development, we should just not expect any metric to be perfect. That's number one. And so what does that mean? What do you do in lieu of that? So overall, you can think of these metrics or evaluators or however you want to describe them as being in two different kinds of camps. One, we think of them as system metrics. The other one would be use case specific metrics. What we've seen is as a developer, when you're starting to build out an application based on the system that you're building out, whether it's simple prompt-based or RAG-based or agentic, which might have any of those other pieces in there as well, you got to think about at a system level, what are the things that you want to, what you want to measure. When you're looking at RAG-based systems, you might want to see, is the response actually adhering to all the context you had or not? You have different kinds of metrics for your chunking strategies, which chunks actually attributed to the response, how much of the chunk attributed to the response. In the world of agents, what we're starting to see as very helpful are things around, what was the overall, did the actual agent complete the task or not? And how do you actually figure that out? That's number one. If that's not done, then where do things fail along the way at the tool level, whether it's an API response failure or is it an understanding failure? To Aparna's point before around the handoff from one agent to the other agent, how did that happen? So there's all these different pieces from a system perspective, and then there's use case specific metrics as well. Now, the important thing here is it all comes down to customizability, which has an element of authorship. It is very important to have more of a metrics IDE at this point for developers to build their own metrics, because at the end of the day, every use case is different. And you as a developer, if you're building a weather app or a travel agent app, you know your use case the best. And so we have to give the developers the tools to be able to quickly author high quality metrics. So customizability is very, very important. The second is adaptability, because the measurement problem is a real problem, but the last mile measurement problem of how do you go from 80% accuracy to 95, 97% accuracy, it's also really important. And that last bit is all about finding the false positives, false negatives, and having these guardrails adapt to your use case as quickly as possible. So I think that's on the tool builders, like us in the room, to actually build out those kinds of the infrastructure and the algorithms to do that. And that's kind of what we've been focused on at Galileo. And this last bit is scalability. Because as soon as you get into production, the big problem is, great, I've got these guardrails, but if they're powered by language models, they don't really scale to millions of data points. So, God forbid your app goes viral. What are you going to do in that case? And how are you actually going to protect every single query that comes in? And how do you protect your system? So I'll just say that overall, to truly build reliable agentic applications, we also have to start seeing not just the here and now of how these things work, but also where the puck is going. And overall, we're starting to see more and more that agent marketplaces are going to become a thing very, very quickly. My sense is that's going to happen this year very, very fast. But the ecosystem will start galvanizing around these new authentication systems. I think Chris mentioned some of that before. New kinds of access control paradigms, new communication protocols. There have been some hits and misses with A2A and some others already. One of them is going to stick very soon. And as soon as that happens, these will start baking itself into the traditional SDLC process, and we'll need the reinvention of that overall tooling layer. So there is this here and now of thinking through, like these task completion metrics, et cetera, but I think it's going to be very important to have a more composable, holistic, adaptable, and scalable system for developers to truly build powerful guardrails.
Yeah, I just want to add big plus one to, I think we're in the space because it's a big problem to solve. These are some of the most freaking complex applications that have ever been built. And the thing is that these metrics is not what it was in the software days where it's like latency. You're not solving that. They're non-deterministic foundational models that are making decisions for your business. And so you're going to put these agents to potentially answer emails for you, go and talk to your clients, go and, I think we've already seen to date so many examples of where these agents have hallucinated with customer data, have said things they weren't supposed to say. And so I think there's a very powerful growing voice in the community that you cannot build these applications without evals today. And there's actually one thing that I think I've seen a lot of developers who are building get kind of confused about, which is model evals versus actually, agent or application evals. You might be seeing all these benchmarks in the ecosystem about, especially when you're looking and comparing, how is the 4.0 model doing against, O3. And so model evals, those are really think about the more like model benchmarks. They're used to help you understand where is a model good at? Where is it, when I'm stacking up Anthropic's models versus OpenAI models, how do those two compare? I think as a developer or a use case builder, you're maybe looking at those models. I think you're actually probably feeling it. I don't know how many of you guys have swapped out your models in Cursor all the time. You're like, hey, it's better for this versus, this model is kind of better for that. I think, start to realize the differences between the models. But as an application builder, you probably really care much more about call it agent evals, how your agent's actually behaving in certain use cases. And there's a lot, by the way, that we're starting to see, some specifics that we're starting to see people do. Tool calling correctness, is it picking the right tools? Is it passing in the right parameters into the tools? We're starting to see teams evaluate things like path convergence. So an agent can take a really long time to get to the final answer, but is it able to consistently over, X number of iterations actually converge to a concrete number of steps to be able to solve a problem? Is it able to do planning correctly? So does the agent, if you have a more of an architecture like orchestration worker, how well does it write the plans? There's reflection. So there's all these evals that are getting very specific to how you build your agent that I think is very important for teams to start to build. And ultimately, I mean, why do I even need evals? It's because, to be quite honest, it's way faster and it's way cheaper than having a human go in and label every single output than an app. But it's just unfeasible. And so I think we're starting to see teams start to use LLM evals not just at the kind of final output stage, but actually at each step of their agent to actually evaluate how good is it at different aspects of the application. One maybe last thing I'd just note to teams is that I think the different agent architectures is really going to become a theme as we go closer to this year. I think many of you guys have read Anthropic's guide about building effective agents, and they have all these patterns. I think each one of those will have different eval approaches. So if you're using something like, um, I'm bringing up the orchestration worker, but if you're using something more of like the evaluator optimizer type architecture, each one of those will have slightly different evals that you might want to use based off of the architecture that you're building. And so I highly recommend teams that you think about evals not just when you're in production, but you actually think about them as part of your development process. And especially for product people, this is now the new world of how you evaluate your product journey. And so highly recommend for any folks who are building these applications to think about it earlier in their journey and to build with evals earlier on.
And I'll say
Yeah, go
something
ahead, Violet.
I think is slightly different than what a lot of other people say. So I've been in machine learning for about 10 years. We've worked on Face ID, we worked on predictive systems at hedge funds, at Microsoft building AR pipelines. And I do agree that evals are really good, but I actually think building agents is actually more akin to building websites than it is to building anything else. And we don't have unit tests for our front end. Yes, if you're Google, you build unit tests for where the login button is, and you ensure that the login button exists on Google Cloud's homepage. But if you're a smaller company, you don't do that because it actually slows you down to build that out rather than go do it. When you're a designer, you don't eval how good your UX is. You build end-to-end product conversion metrics and you do experiments and do something like Launch Darkly or any other experimentation feature to basically swap things out. When you're Amazon, you play around with the color of your button and just look at end business metrics. And I think the idea of evals being bespoke to agents, I think is a little, from my perspective, what I think is if in the end, an agent is just a data transformation tool, it takes data of one type, converts it to another data type. We find some way to tie that conversion to our business metric, and then you can just use the system that you have. Yes, you might want to debug into the prompt that you have because the conversion isn't what you want. Yes, you might want to sample data out of that system in some way and makes it usable. But fundamentally, how good the LLM is doesn't matter. Like I think Aparna said it really well. There's like model evals, and that gives you a feeling for it. But in the same way that I have a feeling for whether flat design is better than better than materialistic design. Material design is like, it's just a feeling, and the best designers build that feeling by iterating over thousands of designs over their career. And like with LLMs, it's the same thing. We all get this feeling for what models are good at, but none of us can ever definitively know. And by the time we build our eval data set, you probably don't know either, because you've probably fallen behind from what the latest model is by the time you've done that. So I actually think the best thing to do with evals is what I call vibe evals. I think it's a lot better than vibe coding. I think we should just vibe eval. And really, the answer to that is just run that sucker, run the damn sucker. Press play and just look at the output of the model, look at the output of your pipeline. And if it's good, it's probably good. Ship it, tie it to a business metric in some way if you have enough users. If you don't have enough users, just talk to your damn users and then just look at it. If you have millions of users, you can probably tie it to revenue in some way or some other conversion funnel. And when we, for example, for our documentation page, what do? We look at what pages people go to from the home page. We just track the cookie across and we know what they did. With an agent, there's probably something very similar you can do for most people's system, which is track the user journey in some way. Whether you want to use a new system, you can. Whether you want to use an existing system, you can. But it's really about just tying the user journey and then just seeing what if the change you made in software impacts your end system. The fact that we have this new piece of software that does something kind of magic is just a tool in our toolbox, but it's not the only tool in our toolbox. And I think vibe evals can get people way further than they think on day 0 to like day 50 or even day 300 without really having to think about what exactly is correct. Because for most agentic systems, you don't have a definition of correct. And most people don't know how to concretely put that together. And to practice, just pressing play over and over again, building thousands of small little systems where you understand the span is likely going to help you get to that point way more than focusing deeply on one system over time.
Can I
Yeah.
respond to you actually, Viva, if we have time? Was that
Yeah,
right?
yeah, please
This
go
is
ahead.
this is actually my favorite part of being on panels because I think you could debate different approaches of this. So Viva, I think name questionable on vibe evals. I don't know if I'm going to get into that one, but I think that like there's one aspect of what you said which I agree with, which is like just build the damn thing, ship it, and feel tied to some sort of revenue or product metric. I think I totally agree with you on that. And I think the places where this gets hard is that, okay, so your conversion goes down. Where's the bottleneck? What are you actually going to fix? What's actually the spot where the,
But that's the same
the
in
agent
software.
Totally. I think in software, the questions that are being asked, though, are typically more questions around where is the application, let's say, slow. And so you start to look, for example, at the tools like Datadog, for example, where you're looking at, oh, is my query going to a database really slow? Is some API call taking too long to go get back data? Here, that equivalent is where is the agent? Like, I'll give you a concrete example. There's some really common use cases now where you're talking to a chatbot to even purchase something. Call it like a chat to purchase
Yeah.
type use case. And so you're noticing that conversion's low on that chat to purchase. Is that because the conversation back and forth with the agent? I've had teams who do evals across, is the tone in that entire conversation consistent? Or does the agent over a period of time kind of, the tone is no longer relevant to what they were
I
previously
think
talking about? Do they no, does the agent have the memory of what the user had talked about earlier in the conversation? If relevant as part of that purchasing decision, maybe 5, 6 turns down. And so I think these are the more nuanced types of things that we're actually seeing teams evaluate is where's the bottleneck in the application? Is it calling the right tool call for that agent to make the purchase? And so I think that's more of maybe where I think for simpler use cases, you could probably just live with the end result. When it gets more complex, knowing where is actually really hard without evals.
kind of, but I think when you end up doing something that's like, for example, Netflix's recommendation engine famously
Yeah.
changes all the time.
Mhm.
You just tie it to the metric of how often do people click on the first link versus the second link, and you just do a feature gate on experimentation and go do that. When we built Face ID, it was the same thing. We just tied it to how does this change? What is the distribution of outcomes that happens? And I
Yeah.
think you tie it to an end metric in some way or form. Anyway.
Yeah. No, this is This is great. This is why we have panels, because we have opinions and different experiences. There are definitely like this term vibe evals. We have to see how that evolves, and there are some comments in the chat I see around that as well. Especially in regulated industries, this is the evaluation based frameworks is really important as we think about this non-deterministic nature of agents, right? So I would like to go towards the last theme, which is about the real world problems. Like all of you are currently building these solutions, then you're dealing with different type of uh, real deployments of these agents and system. We're starting to see, as I think Vikram, you mentioned earlier on, this agent marketplace and more agents coming out and doing things on our behalf, right? So what are kind of the top challenges in terms of trust and performance and trade-offs between them? Chris, maybe start with you, and if each one of you can add like 30 seconds to 1 minute on what you think are the biggest challenges right now. I know in the next year or so there would be way more or way different, but let's talk about what are the top challenges that you're seeing from your customers today, and anyone who's listening to it should think about that when they're building agentic systems.
Yeah, so my first one is actually quite simple, right? The number one challenge that I hear from customers is what we call shadow AI, right? Where is their AI being utilized in my organization that I don't know about, right? And that's a problem of visibility and just being able to scan your various environments and to see what models are being used, and what data you have those models have access to, right? So that's number one. That can be a little bit challenging where we're seeing so much embedded AI in various tools, right? And the appeal to the business user is like, oh, I already have this, I just have to turn it on, right? And this tool already has access to my data. Well, if that's not sanctioned, right, by your responsible AI teams or your governance teams or whatever, they might not have visibility into that. And there may be risks there of leaking sensitive data. So number one is shadow AI, visibility into it. How do we discover and how do we kind of lock that down? I would say that's number one. Related to that is, we're seeing a huge trend around like what we would call enterprise AI assistants, right? So big providers are able to say, hey, look, you have so much of your enterprise data already with us. We can turn on this agent and give you powerful capabilities. And the problem there is that a lot of those environments, they don't really have clean and up-to-date governance of all that unstructured data, which historically organizations have not really put as much effort into governing, right? So kind of controlling that, locking that down with access controls, so that the right people, only have access to the right data, and then being able to not just kind of do that in a offline manner, but then online, when I'm making actual requests, to a model. So for example, and that can be complicated sometimes, if we're doing something like creating a knowledge store or a RAG system for an agent to get access to. So for example, when data is vectorized and stored there, I'm going to lose a lot of the context around that data. I'm going to lose a lot of the access controls and the policy around that data, and now it's just a vector, right? So being able to apply that, throughout kind of a complex pipeline and keep the fine-grained, like file level, source level data access controls and apply that in real time. That's a major challenge that I think a lot of organizations are dealing with. So those are just a few off the top of my head.
Awesome. Yeah, I see a lot of audiences agreeing with you, especially around shadow AI. So,
Yeah.
Vikram, do you want to go
Very good.
next?
Yeah, for sure. So really quick, the big problem that we've been seeing is there's a huge cold start problem, right? Like as a developer, when I don't even know what my failure modes are, because you don't know what the failure modes are going to be. To Aparna's point before, it's not about cost and latency. I have no idea. And so now how do you build the right tests? How do you build a test set? Forget about test sets. That comes much later in the game. So how do I even begin? So in general, when it comes to these systems that are becoming more complex, I feel like we have to kind of rethink the whole developer experience, right? Like shift from these vanilla traces and dashboards towards more of like auto detection of failure modes, and how can that happen? And these models are pretty powerful. Like, so how can we build out some more deterministic ways of doing that? Also moving from vanilla log storage to having more clear lineage around stuff, around specifically what paths were taken. Can you simulate certain paths? Can you simulate paths for the user? So like that's the direction in which things need to move. Because honestly, when we listen to our enterprise customers and in general for moving from POC to production, from production to scale, the big question, hair on fire question for them is, how do I know if this thing is actually going to be reliable, and what are the failure mode scenarios, and how can I know about that beforehand? And unfortunately, like even if they create the right kinds of tests, there is still a lot of hesitation and skittishness amongst them around from moving to production, because the bar is really high, especially with agents. Things are different because now you're going from not just a response being wrong. Unfortunately, now the action is going to be wrong. If you just give the wrong loan, or the doctor says the wrong thing to a patient, that has real consequences. So we can't just ship things, you know. So that's the big problem with agentic systems, where the bar is just higher when it comes to evals and testing. And I think the definition of all of this needs to kind of shift right towards identifying these root causes and failure modes for them, and then converting them into these tests and metrics automatically, and then pushing them into the SDLC process. Versus right now, I see it happening in the reverse order, where we're all saying like, oh, we have these magic metrics. That just doesn't work.
Yeah, it's a good one, and this is a mind shift, right? We have to take, and that's a good way to look at it. So, Vaibhav, do you want to add anything from your perspective, especially when you're building these frameworks and evaluations for folks, and thinking around that? Yeah.
I think the number one thing that we've seen with people building AI frameworks has just been the hardest part is often the hardest part of what has always been true in software is just defining the problem. Once you're able to define the problem, like there's this funny XKCD 1425, if anyone wants to look it up. And I think it articulates the point really well. But for example, let's say you're building a system that has to process bank statements. And this is a thing that we see a lot of people doing. They want to process bank statements. Bank statements come in all different forms and sizes. You could have a dollar sign or a pound sign, and that is fundamentally a different unit. Some bank statements put dollar symbols next to every value, and some bank statements put dollar symbols only in the first value per page. And now you have to go infer that. And LLMs get confused when they don't see consistency. So now you have to build a system around that. Now, the cool thing about bank statements is you get a framework in there, which is you can just add up the numbers on the page mathematically, not using LLMs, no LLM as judge, just like add up the numbers. And if they don't add up, you know something went wrong. And if you add it up and if you subdivide it per page, you can even find out exactly what page caused the discrepancy in your system along the way. And you've basically done what I would call as a traditional MapReduce problem. And you've broken this thing of 1,000 pages as an agent into a MapReduce problem with a mathematical operator at the end to build a validation system in the loop. And I think once people learn how to build these systems with that kind of approach of combining things together with existing systems, and whether you call this an eval or whether you call this just a thing you put in the middle of like adding some numbers together, doesn't really matter. I think what matters is we can add if statements and conditionals on top of our workflows to make them extremely powerful and build the reliability we need, just like we do with security. Software doesn't come secure out of the box. We have to deal with SQL injections. We have to deal with hashing and encryption and all these other things. And the way we make our software secure is we add software on top of it. I think the way you make your LLMs more reliable and more systematic is by adding software on top of it, like the add operator. In the case of like medical records, we see a lot of companies go do this. If you have a patient-doctor transcript and you want to catch certain diseases, like before you go into surgery, let's say you work with like surgical systems, and you want to guarantee that you correctly diagnose the person as diabetes or not, what you can do is you grab information on the transcript and you flag diabetes as a Boolean, not as an array, whether or not they have diabetes, or it might be an enum of diabetes type 1, diabetes type 2, or none. And you grab the patient's record information as much as you can. And when you get the data, you make an API call to your EMR system, not as an LLM agent, just like an API call from that data model. You load the information, you see if it matches the record. And if something changes, you pop up a UI to the doctor being like, are you sure this is correct? Here's the part of the transcript that I pulled information from. And I think you have the diabetes information has changed. And now you've built it into the process and the workflow to be more valuable. And now you can passively collect correctness data about your AI pipeline as well. Because if the doctor hits yes, you know your funnel converted correctly, and now you have metrics for free.
Yeah, I like that answer in terms of the built in the process. So we have like 1 minute left. So Parna, what are your top concerns or things that you're looking at in real world challenges? And then I'll wrap it up.
Awesome. I'll take it home, I guess, for the career. So I think maybe one theme I keep coming back to is the model is a commodity now. I think from where we started, people were I'm all in on the OpenAI ecosystem. Probably by the end of the year, I think what's getting really interesting is people are swapping models as quickly as the next one comes out. Everything's really, funnily enough, just how good you build the wrapper on top of the model. And so, I mean, the biggest pain I see is that there's a lot of iteration happening. People are changing the prompts, they're changing the models, they're adding new protocols, and I deeply think that, one of the pains I hear about every single day is I change the prompt, stuff broke. I change the model, stuff doesn't work the way I wanted it to work. And so having a very evals driven development process where you're able to benchmark your application, you're able to make changes, and then check how good it does on the new model or the new prompt is just a really consistent way to actually build a reliable experience as a product. And for folks who are looking to do that, we do have a completely open source product, Phoenix. You can go check it out. If you want to use a hosted one, there's Arise, but everything from how to eval to how to run guardrails to how to monitor your application. I think Frank, you asked in the chat, how can I customize these type of tools? We see teams all the time bringing in their own specific evaluation prompts, evaluation data sets. But check it out. I definitely think that having the tools to help you move faster is going to help you stay one step ahead in whatever industry you're building products in. So, happy building is maybe what I'll leave you with.
Thank you. And thank you, everyone. This was really some new terms I learned here about vibe evals, the agent marketplace in terms of the shadow AI and a bunch of new things. So I'm definitely going on LinkedIn posting about this session. Thank you, everyone. Parna, Vikram, Vaibhav, Chris, for your time. For all the questions that I was going through it while we were and trying to incorporate in this session as well. I know there is a valuation link for this conference overall as well, and you are free to reach out to any one of us on LinkedIn and other sources as well. So again, thank you for your time, everyone. This was great, and as Aparna said, go build agentic systems and share learnings with others as well on your path as well. Thank you, everyone.
Thank you so much.
Thanks, everyone.
Thank you, everyone.
Thanks, everyone.
So we're going to take a break until the next session starts. So the next session starts at 11:10 a.m. and about 8 minutes. So I'll come back in about 7 minutes. I will be back. And meanwhile, just take a break and we'll get started. Thank you. Okay, we are back. Hey, Bob, how have you been? Great to see you again. Hey, Emil. Good to
I
see you.
am doing great.
Jerry,
Hey, what's up, guys?
Hey.
Jerry, did you find
Hey,
a good
everyone.
place are you still outdoors or are you?
No, I'm good. I found
Yeah, you're
a
good.
spot.
Hey,
Yeah.
Talat, great to see you. Great to see all of you. Did you guys see the poll? So we had this poll, what things should not be automated, right? So this was a good one. I will not play it in full screen, but you guys can actually take a look at this, right? So people are actually worried the relationships are going to be automated, right? So relationships, healthcare, emotions, deportation decisions, and all of
As a graph guy, I have to say that you can automate the creation of some relationships in data.
Yeah, absolutely.
Somebody says wedding proposal.
Wedding, I don't know. I mean, why would anyone actually automate a wedding proposal, right? So
What are you saying? That sounds awesome. That sounds
Yeah.
great.
Yeah.
I would take that in a
Automated.
heartbeat.
I mean, yeah, automated, and then just maybe if there's an agent on the other end as well. I mean, I don't know what's going to happen.
Depends who you're going to marry.
Yeah. So we are going to go ahead and get started. Thanks everyone for joining. We are going to go ahead and get started. And this is, I've been looking forward to actually talking to all of you in the same panel. So we'll go ahead and get started. Bob, Emil, Jerry, and Talat, I mean, thank you so much for being here. We actually had more than 51,000 RSVPs for the conference. I mean, we had just a lot of response, and even now we have a lot of people actually who are joining live. So let's get started. So let's go around, and then what I'm going to do here is maybe you can very quick introduction of yourself, and then perhaps if you can maybe add this with, I mean, your own introduction, the company, what do you do? And then maybe something unusual, surprising insight about context and retrieval that most people don't realize that it maybe the importance of it, or maybe any complexity, anything that you would like to choose. So Bob, you want to go ahead and get started?
Yeah, sure. Right now, or are we good to go?
Yeah,
Okay, wonderful. We're live. Fantastic. Well, hello, everybody. So my name is Bob. I am one of the co-founders of Weaviate. That's an open source AI native database. So something about context windows. Well, it's a context window is just a big array of vector embeddings. So and if we store something, if we want to store and retrieve something, we need a database management system for that. So working with vector embeddings, regardless if it's inside or outside of the context window, is something that I'm interested in.
Thank you. Emil, you want to go ahead?
Sure. So my name is Emil Ephraim. I'm one of the founders and the CEO of Neo4j, which is a graph database. I'm going to claim it's the OG graph database, or at least we've been around for a while now, and seeing a surge of adoption related to kind of the marriage of graphs and AI. A surprising insight about context retrieval. I'm not sure if it's surprising, but it certainly has surprised me that there's a lot of focus still, like years, like whatever, 2 years into this, on kind of unstructured only content. And it seems like kind of that default thing of chatting with your PDFs still seem to be like too prominent of a concept in people's minds. And at least the use cases that we see, it's actually mixed data. It's a combination of structured data with that unstructured data. Some people call it semi-structured data. I'm a little bit geeky about definitions with data. So I tend to call it mixed data. So you have structured data with some long form, kind of unstructured text fields, typically text fields in them. And I think that's kind of the core data that at least we see people most typically use in real use cases.
Thank you, Emil. Jerry, you want to go ahead?
Yeah. Hey, everyone. Jerry, co-founder, CEO of Llama Index. You might have seen us as like a RAG framework, from 2 years ago. Since then, we've evolved our mission. Our mission nowadays is basically automating document workflows with AI agents. I basically agree with everything Bob and Emil said. Maybe just two quick follow-ups. One is I think the quality of your context does matter. A lot of these days we spend time kind of working with customers on just like really complex documents and document understanding use cases and the set of operations you do on top of them, whether it's converting them to Markdown for RAG purposes or extraction into some downstream workflow. That initial step is super important because if you actually get that step wrong, you basically get hallucinated results down the road. And so a lot of the work that we've done is basically on the document parsing extraction side. Number two, and this is kind of specific, but it's just something that we've been thinking about, and we might do a release on this next week at the AI and World Fair, is basically like the Excel is like I've said this before, like a pretty degenerate format. And I think a lot of what you can actually do with Excel is instead of like trying to think of it as a RAG problem, think about it as like an agent with tools. And so just think about it as like an agent being able to write code or kind of like being able to write a set of operations to basically retrieve and transform the results that you want. And so, yeah, we have some cool stuff around there, but passing it over to Todd.
Thank you, Jerry. Hello? We cannot hear you.
Can you hear me now?
Yes, we can.
Yeah, okay. Yeah, sorry. Hi, everyone. I'm Talat from Vectara. I'm one of the co-founders, and we have a RAG platform that's end-to-end SaaS on-prem and also agentic framework. So coming to the question, what has been said already, I 100% agree with that. These days it's hard to get surprised, but I think the one thing we notice from our customers is basically when they try things out, they take retrieval as good enough is okay. But once you go to productionize, good enough is not okay because anything like when your retrieval is not good, it has very like strong implications on the end results that you're getting from the outside. So at that point, they realize that good enough is not actually good enough. So at that point, retrieval becomes a very core part of any agentic workflow that you want to do. So.
Okay. Thank you, Talat. And I will go last. Rajak Val, Chief Data Scientist and founder at Data Science Dojo. And one thing that I found actually quite surprising is that even people who are, practicing software developers and, people who should be understanding this fact, they cannot differentiate between a large language model and an application like ChatGPT, right? So, wouldn't GPT-4o know? So I mean, it's almost like ChatGPT and any model that comes out of OpenAI. ChatGPT and all the models are interchangeable, and that's where you have to explain to them that context is everything, right? So without context, even the best and the most cutting edge model is actually, it's not as useful. So we'll go ahead and get the discussion started. Bob, is it okay if I start with you? Right? Can we go ahead and
Yeah,
get
sure.
started? Yeah. Okay. So
Yeah,
Bob,
sure.
question for you, right? So generally speaking, I think we have set the context. So why is a retrieval system important in agentic AI, and how does a vector database help bring context to an application? Because I mean, I see all these posts, RAG is dead. And this just yesterday, and I'm not exaggerating, I saw vector databases are dead, right?
Yeah,
I
it's
saw
a
that. I said, I mean, I will tell Bob, vector databases are dead, then time to move on to something else, right? So Bob, please go ahead.
yeah, I saw that too. It was funny that post used the SDP. They used the German Deutsche Bahn as a as a visual for that, which I didn't understand that relation. No, it's super interesting to see that. I think that I mean those kind of things are also a little bit clickbaity, but just that gives people the benefit of the doubt of what they are what they're arguing, right? So the argument that's often being made is the context window is so large now that we don't need an external storage engine to store external information. So first of all, I think what's also very important to bear in mind that to do RAG, you don't need a vector database per se. It just solves a very specific problem. So right, so I'll share in a bit what that is. But that's the argument that is often being made. So context window is so large that we just stuff everything in the context window and the problem is solved. Now, what's very interesting, if you just double click on that thing and start to think about it, is that let's say that we would do that, right? And let's say, for the sake of argument, that we would have from a speed perspective and those kind of things, we would be happy with the results that come out of that. We still want to store that information. So if I talk about something and I store that in the context window, I somehow need to store that information. Storing information in a digital system is just what we refer to as a database management system. So a larger context window does not solve the problem of needing to store that information somewhere. Secondly, and I always like to refer back to the original RAG paper. It's literally in the abbreviation, right? It is when you do generation, when you generate something, you augment the context window by retrieving something. So if you have a use case where you have, let's say, I don't know, a random number, 10 million data objects that you want to search for, the argument that's being made in the research paper is, rather than somehow stuffing that in the context window, just offload it and only use the relevant information that you need. Now, so it's kind of, so the argument that's being made, I understand the argument that's being made. So the argument that's being made is like, context window is so large, you don't need an external storage engine anymore. Well, to do that, you need an external storage engine, right? So it's just like a circular reasoning thingy. Now, talking about specifically database like Weaviate, the reason that we, for example, say that we believe that the database like Weaviate so nicely fits with RAG has nothing to do with that it's vector embeddings and that vector embeddings are related to machine learning. No, it has to do that the query that's going in is very often very ambiguous, right? So that's the nice thing. So basically, I don't want to put words in your mouth, Emil, but I could imagine that an argument where you would make like, hey, if you want to start the discovery in a graph, or in our case, if you want to start the discovery in documents that you've stored, you start from the perspective of an ambiguous query. And that is the powerful thing, right? So if you're gonna put stuff in that context window, but the query is ambiguous, then you need to start somewhere. And that's why for semantic search or for vector-based search, or in our case, most of our customers use actually hybrid search, works so well. So it's a very long answer, but to quickly recap it. So it's like the argument of like the larger context window doesn't need an external source because it's now so large. That goes against what exactly is described in the RAG paper. It basically describes, no, it's great to have a large context window, or they get larger and larger, but we want to have an external data source where we retrieve stuff from to be efficient and to store data back into. So that's the argument, basically.
Yeah. So thanks for a very detailed answer, Bob. We use hybrid search, and then we get both the keyword side of it and the semantic side of the context that we're bringing in. But recently we have been seeing that you need a knowledge graph to augment or maybe overcome some of the shortcomings that your context has, even if you're bringing it using a semantic search or a keyword search or a hybrid search. So Emil, can you give us a very layperson's explanation of why after hybrid search you would still, or you might still need a knowledge graph?
Yeah, so we see three drivers when we look at kind of people choosing to use Neo4j as part of these types of applications. It's accuracy, it's development productivity, and it's explainability. So I'll double click briefly on each of the three. I think accuracy is maybe the most intuitive one. Like, I don't know, maybe, but I feel like we've run a massive RAG case study, like humanity has, over the last, whatever, couple of decades, right? Which is called the web, right? And some of us were around back then, some of us were not. But like back when, like in the late 90s, when I started going out on the internet, like Alta Vista was king of the world. And some of you might be Googling what Alta Vista is right now, but that's a search engine kind of pre-Google. And the problem Alta Vista had was the Alta Vista effect, which is basically you search for something and you got so many hits, and the real one was like on page 38 or something like. So you can like flip through a bunch of these things. That's what the world looked like kind of pre-Google, right? And Alta Vista used basically inverted index, BM25 like type search, right? And then Google came along and said, hey, I'm going to do that. I'm going to search inside of each document, right? But I'm also going to rank it based on the links. So page rank, right? Which is a graph algorithm called actually eigenvector centrality. But it doesn't matter what it's called. But basically use kind of the graph to rank and find the top 10, like the top 10 blue links kind of thing. And all of a sudden, we all found like the answer in the first page, right? The first top 10 links, right? It turns out that the quality of your RAG application is directly proportional to what of the documents that you get out of the RAG corpus, like your hundreds of thousands. What was your example, Bob? Like 10 million kind of objects, right? So which are the top 10 that you choose? I just choose 10, like top n, small n, right? And so I think there's some precedence that using the signal of how things fit together gives you higher accuracy. And there's now been a ton of research kind of proving that out. And this is not instead of vector search, it's in combination, right? And this is like, so for example, Weaviate and Neo4j, we do a ton of work together, right? Like if you go to our blogs and you'll see that. It's like, okay, stand up Weaviate, use that for the vector search, stand up Neo4j, use that for a knowledge graph. That's really powerful. Kind of like, we're not next to each other right now, but like Bob and I would be doing like, that thing, right? Like the heart little thing, right? Right, Bob? Yeah. That kind of thing, right? And so that's the first one, accuracy. And then I think the second one is, okay, what's nice about graph space compared to vector space, right? Vector space is very opaque for a human being, right? It's very just binary, right? Graph space is like, okay, you have a thing and it's connected to another thing. It's like, I'm a user which is connected to a support article and other users have voted on that. Like, it's explicit, you can touch it, you can feel it. And so when developers build applications, once they've created the graph, that's the big stumbling block for graphs. Like, how do you create the graph, right? But once you have the graph, right, then developers love the fact that they can see the information, right? And that gives us also the third benefit, like the explainability piece, which we sell into like all the big banks of the world and like government and that kind of stuff, right? And they love the fact that they can understand, like they can follow along in the graph and understand why did they choose these top 10 or top 20 documents. It's because they visually navigated in this way. So that explainability is like the third benefit. So those are kind of the three drivers that we see: accuracy, developer productivity, and then explainability.
Thank you, Emil. So I will use your and Emil's answer as a segue, and then build on top of it. So now that we have the context, whether it is coming from vector or not a vector, any other source, right? Could be search, could be a SQL database, could be anything really, or for that matter, knowledge graph or graph database. Now, is that enough, right? So because there's more to it, right? So once you have all of this context, you are going to actually do some reasoning and planning on top of it, right? So Jerry, you have been a leading framework in industry for a long time, and now you mentioned that you're working on this more a general purpose document processing framework. So can you tell us a little bit about why is reasoning and planning actually important in all of this? I mean, why can't we simply get the context and hey,
Yeah. I mean, I guess reasoning and planning are kind of or fundamentals of like an AI agent, right? I guess you could argue if you didn't have reasoning and planning, it would just be like a one-shot outline call. No, I think it's a good question though, and I would just like slightly reframe it to basically what are some general like architectures that you want to use reasoning and planning for different types of use cases. We talked a lot about like context and storage, and I think Emil and Bob have a lot of experience on like the fundamental like I guess data models and underlying like storage systems to basically represent this massive amount of context. In terms of reasoning on top of enterprise data, I've seen a spectrum of basically like applications ranging from things that are a little bit more constrained to things that are a little bit more unconstrained. And what I mean by that is like you can either have constrained reasoning architectures where you basically do like step 1, then step 2, and step 3. And those are typically better for things where you need to automate like an end-to-end business process, and it needs to be somewhat predictable and reliable. And so, for instance, like some of the use cases that we're working with include like, data sheet extraction or like invoice processing and reconciliation. Those are basically like business processes that, typically a human might have to do in terms of like a rote or a routine operational task. And you can basically codify as part of an agentic workflow, but you don't really want that agentic workflow to do like basically arbitrary things. You just wanted to solve that task and solve it well, because if you do that well, you already provide a ton of efficiency gains to the end user. And usually to make it like a little bit more agentic and multi-step, it helps to have the confidence that this thing is going to work relatively well. And so you define the parameters of the agent such that you maybe give it access to one tool in stage 1, and then in step 2, it has to like do this other thing. And then step 3, it has to do this other thing. So you basically have pockets of non-determinism to basically reason over unstructured data, but it's kind of wrapped in this overall deterministic architecture. We have an overall agent orchestration framework that helps developers basically build these types of constrained workflows, starting with that. And then I've seen that those types of workflows typically work better for like these kind of more end-to-end business process automation use cases. On the other end, you can basically have something that's a little bit more unconstrained. And what I mean by this is basically like a general like React agent or an agent that can write code with like a set of diverse tools. And for those, I typically, there's usually a trade-off between like how broad you make it, as well as like how much human in the loop needs to happen. Because usually like the more tools you give to the agent, the more human in the loop you need to introduce. And that's how you get to these like chat assistants, where maybe it is an agent with access like, and different tools, but you really need the human in every stage of the process to really guide the agent. And those types of use cases tend to be a little bit more for information gathering and then surfacing the information back to the user, and less on kind of end-to-end automation of the decision making. And so I see a spectrum between the two. Like I call the former one like automation-based UXs, the latter one kind of assistant-based UXs. And the core architecture pattern is either like a constrained workflow or unconstrained workflow. And these are different ways that you can basically kind of make use or interact with the context from your enterprise data. The former one's more given a data, achieve a certain task in a routine way. The latter one's more, work with the user to do like information discovery, chat, so on and so forth, right? Like the standard patterns people are used to with ChatGPT.
Yeah, thanks, Jerry. So Talat, coming to you, right? So a lot of these vector databases, a lot of these frameworks, reasoning and planning frameworks, they are available in open source, right? So I mean, any decent dev can just go and clone these repositories and get started, right? So why do we have, you are working for Vectera, you're the founder of Vectera, actually. Glean is there, Copilot, Amazon has products, right? So and all of that. So what is it that these companies that do for enterprise that, I mean, why can't I just go? I mean, if I'm a decent dev, I should be able to just clone this repository here, that repository there. What does it really take to build an agentic AI system, or generally a RAG platform that I cannot build myself? I mean, what is the value add? I mean, how do you build? What are the complexities involved in building a system like this?
Yeah, thanks. That's actually the premise of the whole company, basically. I think the biggest thing we're seeing is that even some of our customers, they exactly said what you said. Oh, I can go off the shelf, take this, take that, and do this myself, including models, because we have our own models as well, right? But doing something as a prototype is very different than going to production. Okay, some of those production things Emil already mentioned, like even adding traceability, where you can explain why did this result come back like this, right? So doing production at scale requires way more than what you need for a prototype. A prototype you can build very quickly today. You can even use agentic coding to build a prototype for you. We had customers who did not sign up with us. They went away, they built their own stuff, and then 3 months later they came back, right? So there's stuff like scaling, but there are also small features that are missing from some of these out-of-the-box options, right? For example, one of the customers, they wanted list-based filtering, okay, for their vector search. And the stuff they were using out of the box did not have that. Another customer wanted to integrate with their LDAP. A third one wanted UDFs, user-defined functions, to apply when they were wanting to re-rank their results. So there are a lot of features that are missing out there. Maybe 5 years later, a lot of these things, when they settle down, the open source and all that kind of stuff will have those features. But still, when you go to production, you still need a lot of additional handholding. There's even security, right? Like how do you ensure that this deployment actually is secure? Then come the hyperscalers, right? Like you can go to Google, you can go to Microsoft. Another trend we're seeing is that a lot of companies, they do not want to send their data to the cloud. A ton of this data is actually very confidential, right? So they want their applications run inside their own data centers. That's why like a lot of companies, they provide on-prem solutions as well, and that's what we are doing as well, where we don't even have access to the deployment anymore. Like they will switch off the access to the internet to that particular application, and then just access it within the company. And then when you talk about companies like Glean, they are one layer above us, basically, which means that they are an application. At their core, they could actually use us to build what they're building. So we focus heavily on how to build a platform exposing APIs to do RAG well, to do agentic well. We have a lot of emphasis on just the R part, basically, the retrieval part, how to do that well, because that's, like everybody's saying here, the context you give to the LLM, the generally defined answer matters a lot. And most of these companies, they have millions of documents. You cannot throw everything there. If you want to do a small demo with one PDF, they will work very well. You can put that on as a context, but apart from that, it's not gonna go far. And then comes expertise, right? Like you need multiple components to build this. You need to be good at prompt engineering. You need to be a good backend engineer. You need to be a good machine learning engineer to know which models can be used in what part, right? You need to be a good product person as well. So do you really want to have 50 people here to do this basic thing? At the end, it's going to cost you way more than a company that does this, like that's their bread and butter. So that's I think the value gets added by companies like us.
Okay. Thank you, Talat. So my next question is going to be, any of you, feel free to, jump in. The model context protocol. So, that's there's a lot of buzz around MCP at the moment. So can one of you actually just explain what problem does MCP solve? And for someone who does not quite understand everything, but they just a beginner in LLM applications.
Yeah.
What problem does MCP solve?
I can take that one. So it's easiest to explain based on an example, I think. Right. So we have a customer that's an email client, and if I use the RAG functionality that they have over my emails, and I ask, for example, flight. So it's like, what time does my flight leave today? It does very well. So it gives me the exact answer that it says, like, your flight is leaving at 2 p.m. from there and there. If I now ask the follow-up question and I say, Which terminal is that? The problem is that information does not sit in the email. So it can't answer the question because it can't retrieve more information from that email. So what you can do with MCP is that there's probably an MCP server that takes care of like, departing flights and arriving flights and that kind of stuff. So it can basically ask, well, for this flight that is departing on at this time from this airport, what's the gate? And then it retrieves that information and sends it back. So what you start to see is like a whole network, like a knowledge network, if you will, a knowledge graph. But the whole.
I'm sorry, there's another word. There's a synonym for network, Bob.
Yeah, yeah. I said it, and I was like, I'm waiting for him to
The
step
word
in.
knowledge is
Yeah,
your
yeah.
trigger. You start smiling the moment
I
somebody
can do this all
mentions
day.
knowledge, right? So
Exactly. So and so we can extend that with more knowledge, and that's basically what it solves. So it's like think about it. If you're at home, you're cooking something, and you go like, oh, what's the recipe again? You take a book and you look in the book what the recipe is. Well, MCP is basically just an encyclopedia of information that your system can tap into, and because it's generic, we can just connect them all together. So that's how I look at it.
So just to add to what Bob said, I think that's very good. But let me go 10,000 feet even higher, right? I think LLMs, the natural input for them is natural language, right? You say stuff in natural. On the other hand, you have systems that are exposed through APIs, right? So now how do you make these two connect to each other? Their input is completely different, right? So MCP basically solves that problem. How do you make LLMs talk to APIs? So all you do is like you wrap your APIs around the MCP server, let's say, and then now all of a sudden these LLMs, they know about MCP because that's a well-defined protocol that all these LLMs are supposed to understand, and that gives them the power to know that, okay, fine, for this, I need to call this MCP server, which knows these parameters, so let me add those, and that's it. So it's basically like a interoperability way between natural language LLMs to understand and anything else that uses APIs, basically. So.
And so we have so many. So Jerry, you wanted to add something?
Yeah, sure. I mean, I agree with everything that was said. Let's see. The only things I add is this idea of like an agent calling like tools that's not really like a new idea. If you've been around like 2 years ago when like these frameworks first started and like LLM started introducing like function calling capabilities, people were already doing this. The main benefit of a protocol is it's something that everybody can agree on as a standardized interface. And so therefore, you don't need to do the work of reinventing that interface for every new application that you build. And also there's interoperability with existing tools like Claude and Cursor. And so, these days, the nice thing about MCP is that if you built like an MCP server, it'd basically be out of the box compatible with your ChatGPT, Claude, Cursor, whatever agent front end that you use. And also, if you were to build like a AI agent on the client side, it'd also be interoperable without you having to figure out the interfaces with a bunch of the predefined MCP servers. So really, it's a nice way to basically standardize how agents interact with the external world. And I think to Bob's point, I mean, I think a lot of like us, like the kind of like overall theme around these like vendors is basically how you like store and index a lot of like enterprise context. And in the context of agents and MCP, you can kind of think about it as just like MCP servers that provide agents with, context grounded on enterprise data, right? So it's really like a generalization of this idea of RAG. Agents being able to reason with these external services that can store and index large knowledge collections and let you take actions over it.
Yeah. So thanks, Jerry. So your enterprise data can be in a lot of different systems, right? So I can have my Salesforce, I can have my SQL Server, Neo4j, BB8, right? So I can have so many different data stores. So who creates these MCP servers? I mean, where do I get this MCP server, right? So, do I write MCP server for each of them? How does it work?
That's a good question. Maybe I'll quickly answer this. I'm actually kind of curious to hear Emil, Bob, and Todd's thoughts. I do think every SaaS vendor is going to create their own MCP servers in some way. Like Salesforce, SAP, every B2B SaaS out there is going to create some like servers that basically, as long as there's some sort of like system of record where they're storing some sort of data, then it makes sense to basically offer that up as an endpoint to basically plug into your AI agent. Of course, there's some like, tricky parts right now with auth, like data privacy, all that stuff. I'm sure, that'll be figured out in the medium term. I think one of the benefits I see though of still like, being able to index context and kind of put it into a database is depending on how you actually structure and format the data, you can really like be able to analyze it in different ways. And I think that's why, graph, vector, and general retrieval interfaces are so important. Because these vendors will be able to provide access to their systems to look up like specific piece of information. But sometimes you do want to index like a knowledge base across your entire enterprise collection. You do want to create like an ontology from it. You might want to like, create a SQL collection from it too. And so I think like these data systems are so important in being able to give the AI agent like a different view of that data. But yeah, curious to hear other people's thoughts.
Yeah, I guess there are two things there, right? Like one is where do all these kind of MCP endpoints come from? I completely agree. I think all the vendors will do that. The SaaS vendors, we have one. Everyone will have like an MCP endpoint.
I think
seems right to me.
Weaviate and Neo4j both have an MCP server officially.
Yeah, that's right.
Already, right? Yeah.
Yes.
And I think some of this is like when I look at MCP, like I almost think back to like the early days of HTML. This is like the value of an underspecified protocol, because like it is so amazing and it's so not amazing sometimes. You look at it, it's like really easy to throw up, get like an MCP server, and there's a ton of stuff that's not like they didn't want to think of security, they didn't want to think of identity, there's like a ton of things that haven't been done yet. But I think that's part of why we just saw this explosion kind of MCP kind of endpoints out there. I think the second thing that you said, Jerry, I think is super interesting. And I think there's this big, I mean, maybe I'll dramatize, like this big battle to be played out over the next several years where I don't think we know yet which layer is the integration of all these data sources going to happen, right? Because we've spent 15, 20 years right now since the early days of Hadoop. Yes, there were like kind of data warehouses before, but let's kind of start from that point of view where we've said, okay, we're going to grab all the data out of the big systems of records inside of the enterprise. We're going to shove it into like initially Hadoop and then Spark and then whatever your modern data platform was, Snowflake or Databricks or something like that, right? And that's going to be how you get this consolidated view across of all your data, right? Now we're starting to see this other vision emerge where it's like, you know what? I actually don't need to take it all out of these systems and shove it into one single kind of data platform, be it Weaviate, be it Neo4j, be it Snowflake, or like anything like that, right? My agents can just sit on top of it, and the main integration is happening at the application layer rather in the data layer, right? And that would be like, I call it the Salesforce kind of argument or the ServiceNow argument, or something like that, right? And then of course the data vendors, myself included, right? Like, and Snowflake and Databricks, like, no, it's way better to do it in the data layer. And it's unclear to me how that's going to unfold. Like, it'll never be 100% in either. Like, we're going to end up doing both. Is there an 80-20 here, right? Where like actually kind of proportionally more of that, like kind of that influence is going to shift away from the data layer of the stack. Obviously, I'm betting not because that's where I sit, but it's actually not clear to me how it's going to play out. I'm not sure if other folks on the panel have any thoughts.
Well, so I don't know how it's going to play out either, but I think with looking forward, it might also be interesting
do you agree
to
with
look
the framing like of that?
Yeah. So maybe I don't know, but so to think out loud here, I think it's super interesting also to look at it from a historic perspective, right? So just I'll try to get to an answer to your question, but based on historic perspective. So if you look at if you look at APIs, there was also when I started my career, the way to write an API was a RESTful architecture, and What's so interesting about RESTful architectures, for those who don't know, is that it's mostly about the language that we use, right? So, for example, if you have like a RESTful endpoint, you use plural. So, hey, you never say /customer, but you say /customers, right? And then if you did a get on that endpoint, you got an array of customers. And if you did /customers / the ID of that one customer, you got one object. And so the RESTful architecture is very much about language. So how do we use language to explain to developers how to interact with the API? Now, I think what cannot be underestimated today with something like MCP, thanks to the models, is that a huge problem that we've had, like it just in general, like the world had, like in data, was that we needed a human to interpret the language that was in the API. So you could not have two APIs talk to each other, even if there was logical language in there. That then there always had to be a human in there to interpret it and to write it back. And the only thing that the RESTful architecture dictated to us was like how to write it that people would understand it. What we can do now is have the model understand the structure of the API based on the language that's in there. That's a revolutionary. We have never been able to do that. So we're quickly going over, okay, then we have MCP and then we interact with the APIs, great. But this was a problem that was like, it's unbelievable how large that problem was. And I think also relate, if you think about like the semantic web and those kind of things, how people, and I think, Emil, you know way more about it than I do, but how people disagreed on how to call things and how to define ontologies on the semantic web. And now we have a model that says like, you know what, I'll take care of it. That is unbelievable. So we removed the human in the loop there to connect these things together. So now trying to answer your question, I don't know on which level this will take place, but I think the fact that we now having models routing the traffic between these APIs without human intervention is just that's unbelievable. That was unthinkable even 4 years ago, 5 years ago. Not really answer your question, but yeah.
I think Raja, you're muted. So I think I agree with what has been said, especially like when Jerry said that all of these vendors are going to have their own MCP servers. 100% agree there. I think I'm older than Bob. Like when I started, there was this XML based SOAP protocol where people were trying to specify everything in XML. Right now, the good thing is that with MCP, these LLMs can understand and call them automatically. So that's the big change that's happening. And lastly, like even if you look 6 months ago, people started to do federated search. Now, if you connect that to agents and what I said earlier, that companies have so much data, let's say in Salesforce, in Google Drive, Dropbox, this and that, right? They started asking, do we need to reindex everything and put it in a vector store or a keyword-based store or whatever, right? What happened instead was a lot of people moved to the direction of federated search as well, where you have a query that comes in, you send it out to these systems, you do the search themselves within their system, and now in your end on the agentic side, you're basically doing re-ranking. That, oh, I got results from Salesforce, I got results from Google Drive, got results from which one are the best results for this particular query, and let me do that too. So I think that's the direction that things are going to go. Everyone will have their MCP server, will very well define description, because that you need that for the LLM to know which tool to call when, and then even federated search was going to just be MCP based. So.
I love how we're dating ourselves based on the protocols. So
that's what I was thinking actually. Yeah, you can almost date yourself when you mention which technology you worked on. So time flew by actually, so we did not have a lot of chance, and we are already toward the end of the session. So I'm going to actually direct a few questions here. So I'm looking at one question. This was okay. So these MCPs, so Amit Kumar, question, these MCPs will be hosted on which server? I think partly we answered that part, but example shared about flight terminal info. how will I get over the email? Basically, I queried, and now if I have to get that email, what would the flow look like? I think that probably that is the intent of the question. There's a lot of questions actually.
I think we're going to see an MCP server, which is an index of MCP servers. So that you just direct to one MCP server, and then you say, I want to know something about flight terminals, and then it says like go over there to that MCP server. I would not be surprised if we start to chain these things together.
Yeah, and then you're basically reinventing a search engine at that point. But anyways, I agree with what Bob said.
And these are for the public MCP servers, right? Because definitely there are going to be some authenticated MCP servers, but more like so Bob, what you're envisioning is some kind of search engine or some kind of aggregator of all the MCP servers that are public.
Yeah, so I don't know. I'm going to assume that somebody's already working on this, but if you just keep brainstorming about this, let's say that you have a bank, right? So you can have an MCP server for your, I don't know, JP Morgan bank account, and then the MCP server tells you, well, this is the type of authentication that you need to bring to this MCP server to get access to it. Well, and so on and so forth. So that's what I meant, that you can keep chaining these things together. They just talk to each other, and then they say like, if you want to get information from me, this is what you got to bring. Think about credit card transactions, right? So if you have an MCP server and you want to buy something, they say like, well, this is how you need to bring your credit card information now, and so on and so forth. So it's like just a whole network graph of of MCP servers interacting with each other, and also telling each other how they want to authenticate, how you need to authenticate, what kind of information you need to bring, and so on and so forth. I would not be surprised if I now search for and now I feel old if I say Google, but search for an MCP index, then probably somebody's working on that.
So just to add to Bob, like what's happening today is that they call them tool registries. So you have MCP servers and they have tools, and then you register in this central service called a tool registry, and then your LLMs or whatever, they can go search over there. And that's exactly what Bob is talking about. It's just it's in infancy basically, right? So it's gonna get much better than what it is today. The particular question here asked is about where they're gonna run. A lot of them today are just running locally. On custom, because a lot of agents are not running in the cloud. They run on your machine, like the agents that write code, they are on your machine, right? And people are not very comfortable either. The first version of MCP did not even have very good authentication and authorization mechanisms, right? Those are now changing. They move to the cloud. And in this email example, you can imagine that the SMTP server is replaced by a MCP server, right? So it's the same information that needs to flow in both directions. It's just that exposed through MCP. So.
Thank you, Talat. There's one more question around how does this come into play? I mean, there is MCP, and then more recently, A2A has been also making waves. So how does MCP come into play, and with A2A, and what does the overall picture look like?
I don't know what A2A is. What is that?
The Google agent-to-agent communication.
Google's agent-to-agent.
Sorry,
there's
Google.
conceptual differences. Yeah, no, there's conceptual differences, like MCP is agent to tool, so it's like a request response type thing. A2A is more like agent to agent, so theoretically you could have the agents pass messages back and forth. In reality, they're basically competing protocols, and so I think basically the roadmap's like the exact same for both of them. MCP is going to do more A2A stuff. A2A is going to do more MCP stuff. In the end, it's basically just whatever protocol is to use is the one that everyone agrees on. And so, you could just like sit back, watch, eat some popcorn, and see what makes sense, right? But I will say both of them seem reasonably big enough that they're here to stay.
So you consider them competing, not complementing?
I mean, they're not going to give you that as an official answer. But I do think, like, if you look at the roadmap, it's all kind of converging on the same thing. Like authentication, doing like instead of request response, doing some sort of like back and forth message passing. I could see a world where they both coexist. I don't know if that's going to be the case.
Yeah. Sounds good. Any other thoughts on this? The Google agent to agent?
No, I 100% agree with what Jerry said. And Google recently announced that they accept the MCP protocol as well, right? So it's gonna be hard to see how MCP goes away in favor of A2A.
Yeah, sounds good. So generally, we have only 2 minutes remaining, maybe a minute and a half. So maybe I will go around the room. What are you most excited about, right? In terms of, I mean, whatever you're working on, what is it that you find most exciting in the context of, you know, the agentic AI or maybe retrieval context? Anything that you would like to mention?
I'll throw out two things. One is, we spent a lot of time talking about RAG and all that kind of stuff like 12 to 18 months ago. And at least for us, we saw a lot of experimentation, and we sell primarily into the enterprise. And honestly, up until end of last year, it was mostly kind of stuck in POC mode. People were like exploring and that kind of stuff. Holy crap, has that changed? You know how people say it's going to be the year of agent, it's going to be the year of AI in production. It's like, wait, because some Gregorian monks, thousands of years ago, like it's just going to shift on Jan 1st? Really? That's kind of what happened this time, right? So we see a ton of stuff moving into production right now in ways that it just didn't last year. So that's really cool. And then another thing I'm excited about is agentic memory. There's a lot of startups building agentic memory on graphs, and like I have a graph view of this, right? And there's we talked about MCP. MCP actually include a tiny little 300-person agentic memory, kind of in-memory graph, right? And so there seems to be a lot of kind of fit between graphs and agentic memory. So I'm really excited. But that's like where RAG was maybe in end of 23 or something like that. So those are two things.
Thank you, Emil. Anyone else?
I can go. So it's like I hope people don't mind that I'm gonna take a Weaviate example here, but we've released 3 database agents, so baked into the database, and one specific I want to highlight, and that's the transformation agent. And what you can basically do now is, in between your code and the Weaviate sits a transformation agent, and you can basically prompt it with things you want it to do with your data. So it can update data, it can clean data, and those kind of things. And that is something that I'm extremely excited about. So these really baked in agents in the database. So that would be my answer.
Thank you, Bob. Jerry, Khaled?
Yeah, I guess it's kind of related to what Bob said. I'm excited about agents that can actually automate like the data ETL piece. I think I've actually mentioned this since like 2 years ago. But I think with the increased reasoning and just like extraction capabilities of agents, just automating data entry, processing, transformation end to end, and especially with the advent of MCP, kind of like what Emil and Bob said, you might actually have to do less data pre-processing for agent to actually get value out of it. And so just like how do you, there's like the entire modern data stack, like Databricks, dbt, Looker, whatever, you got a bunch of analytics of your data. How do you actually just automate the entire process from like, unstructured information connection to, the structuring of that data, getting insights end to end? We're kind of building some stuff in that direction, not all of it, but in general, I think that's a fun thing to think about because a lot of it relies on multi-step automation.
Thank you, Jerry.
Yeah, thanks. So I think I agree with the panel here, but just to add to that, I think the most stuff that I'm most excited about is the unknown, basically. The rate at which this field is moving is, my God, like I don't think I've seen anything like this, and that's what everybody's saying, right? Every morning you wake up, there's like something new, basically, right? Coming from here or there, some company or some different country or whatever, right? So that's the most
and crazy
exciting part.
valuations as well, right? So
Exactly. Yeah. So the most exciting thing is the unknown. What's going to happen today? What's going to happen in 1 year from now? It's crazy, basically. So.
Yeah. Okay. Well, we are 3 minutes over. So thank you so much, Bob, Emil, Jerry, and Khaled. Great having you.
Thank you.
Great to be here.
Yeah, thanks.
Yeah, it was wonderful. Thank you.
Thanks, everyone.
Bye.
Cheers. Bye.
So we'll get our break started. We'll be back in about 7 minutes, and we will come back with a panel, or rather a tutorial on tutorial on optimizing agents in the cloud, and we will have Hannah and Anurag from Amazon Web Services. They're going to talk about how do you create and optimize agents in Amazon Bedrock. So we will go ahead and I will go off screen, and we will be back in about 7 minutes. Hi, Anurag. How are you? Hi,
Roger, doing
Hannah.
good. How are you?
Great to see you both. How's everything going?
Good, good. How are you?
Doing well, doing well. Yeah, so you can go ahead and get started and get set up. I will be out of your way in maybe 30 seconds. So start sharing your screen.
Yeah,
And
let me share my screen, make sure it's visible. Give me one quick second. Can you guys see this?
Yes.
yes, I can see the screen.
Yeah, I get started now.
Okay, I will be out of your way then. I mean, you are good to go.
Wonderful. Well, thank you all for joining. We are here to run this session on building, optimizing, and scaling AI agents on the cloud. Here we have myself, Anurag Bhagat. My name is Anurag Bhagat. I'm a senior strategist with what's called GenAI Innovation Center at AWS. Along with me, I have Hannah. Introduce yourself, Hannah.
Sure. Yeah. I'm Hannah Marlowe. Great to be here today, and thanks everyone for joining. I'm a senior manager for model customization within our Generative AI Innovation Center.
In this session today, I think we'll talk about practical approaches to balancing accuracy, latency, and cost while scaling agent architectures on the cloud. We'll start by discussing what are agents, just to level set their definition. We'll talk about why are they becoming more and more mainstream. At the same time, we'll talk about, even though they're becoming more mainstream, there's still a lot of challenges with agentic systems. We'll discuss those briefly. We'll talk about orchestrating multi-agent systems. We'll talk about optimizing their deployments on production environments and on the cloud. Towards the tail end, we'll talk about real examples of a multi-agent system and a demonstration using Amazon Bedrock to show how these various pieces could fit together in actual practice and in reality. Quick brief on our team within AWS. We are part of a team called the GenAI Innovation Center. We are a team of strategists and science people. We have data scientists, machine learning experts, deep learning experts. Our mission as a team is to help customers design useful solutions quickly at scale for our customers. We pair our science and strategy experts with the customers in a very mechanized process. Our goal is to help customers launch generative AI into production in a very risk-free fashion. And our goal is to see GenAI applications get to prod as soon as possible. We do that in multiple ways. We provide hands-on keyboard support to our customers. We also provide advisory guidance for the right use cases. Just talking about generative AI overall, I mean, I think we all know the story, but just to level set, generative AI has evolved quite a lot in the last few years. It's relatively new, but it's still evolving very, very fast. 2023 was the year of proof of concepts. From that, we saw 2024. As we work with lots of customers, we saw a lot of these POCs getting into production. We heard lots of noises around, hey, it's in prod, that's good, but when are we going to see value? So in 2025, we've seen customers focus a lot on delivering business value, at the same time maintaining concerns of security, privacy, responsibility at the same time. What has happened in parallel, along with generative AI progressing from POCs to production and value, is we've seen a very rapid evolution of agentic AI. In the very beginning, we had seen agentic AI being used in very simple assistant kind of applications. Which used a simple set of rules, which were trying to automate very simple repetitive tasks. But that has progressed very fast and very rapidly. Now, what we are seeing at this point today is generative AI agents. We are moving towards a fully agentic world, which is intelligent. We will see multi-agent systems making complex decisions and coordinating effortlessly with less and less human oversight, which could possibly transform the way we work and innovate. And we expect to see this happening over the next few years. We're still probably midway into the journey. We'll see a lot happening over the next 3 years. But the whole point is we're seeing a lot of evolution in this space, and the amount of agency we are seeing is increasing day by day with agentic AI. Now, just level setting what agents are, because there's lots of definitions out in the industry. You want to make sure we level set on that. The way we describe agents are they are autonomous systems that can plan, reason, and complete multi-step tasks on behalf of humans. Now, how to do that? They break down high-level objectives into executable tasks, what we call planning, or some version of that. In terms of actually accomplishing tasks, what they do is they use tools, information made available to them, what are actions. From then, what they do is they're actually also capable of observing the results and updating the plan. This is actually fairly important because we don't want them to be deterministic processes. We want agents to be able to look at their environment, observe what's happening, and adapt to what's happening. So three keywords: plan, act, reason. An example of this could be instead of just answering questions about available meeting rooms, an AI agent could actually access your calendar, check people's availabilities, send out invites, book a meeting room. Once that happens, you might see some declines. It may actually come back to you and ask, hey, is this person crucial? Is this optional? And based on that, it may actually revise the invite and do that over and over again. Now, we'll quickly talk about why agentic AI is at the cusp of a large amount of adoption, why it's becoming ready for enterprise adoption today. First of all, we've seen a dramatic improvement in the reasoning capabilities and reliable tool execution for models. We see a lot of reasoning models at the top of the LLM leaderboards. This capability, combined with their ability to process unstructured data, unlocks new areas that we were not able to automate earlier. Secondly, and really important for enterprise adoption, the economics for automation have shifted a lot. We've seen a 10x or even larger reduction in cost per token for frontier model performance, which makes the business case for using agents much feasible. At the same time, we talked about in the past how agents need to look at the environment and evolving requirements and do updates. This was earlier a blocker in earlier approaches. This adaptive planning and reasoning, along with the price performance that we see today with the models, allows for a more robust workflow automation and higher ROI. All these things combined together are leading to Gen AI use cases evolving from outputs to outcomes with agentic AI. All that put together, what we see is some projections which are talking a lot about using agentic AI. This statistic by Gartner talks about how in about 3 years, 15% of all daily work decisions will be made by AI agents, which is huge. Now, one thing to be really aware of is agentic AI is not really a magic wand. And just because everybody is developing agentic AI applications, it doesn't mean it fits every single use case. You have to be really careful about when to use agents, when not to use agents. One key advice we see based on our experience with customers is you should start simple. You should use traditional workflows for predictable tasks. If it's a very clear workflow with no decision making required, you should not use agents. You should use agents for complex, unpredictable scenarios where you actually want the model to be able to reason and think through stuff. So the kind of best use cases for agents are tasks which require flexibility, adaptability, tasks which might require a multi-step reasoning process. You might have to do a dynamic tool selection where the solution itself might not be predefined. As you do that, some key considerations for agentic AI, which are very similar to what you see with LLMs in general. You have latency, you've got cost. At the same time, you have to think about task complexity and whether or not you need to adjust your workflow mid-task. As you build agentic applications, you've got to be There's a lot of trade-offs between latency, cost, and task performance, which are really important for agentic AI. And these are, again, not very different from what you see for traditional LLMs, but these have different flavor given the complexity of agentic AI. Accuracy, as we all know, LLMs tend to hallucinate once in a while, but as you have multiple LLM steps chained together into an agentic AI application, those hallucinations could tend to compound, and hence accuracy becomes a bigger challenge for agentic AI. Same thing for cost. A simple LLM inference could cost you a certain amount of money, certain number of tokens, but as you have multiple things chained together, you could rapidly have lots of tokens being used for a single call, and hence cost becomes a bigger constraint. Same thing for latency, because you have multiple LLM calls, latency could become a big challenge. And hence, when you're designing agentic workflows, there are multiple optimization considerations to be balanced. At the core of these is the choice of language models, which has a fundamental trade-off between performance, cost, and latency. Smaller and faster models tend to reduce your operational cost and be faster, but they do, of course, sacrifice in quality and reliability of outputs, which is a challenge as we compound errors. There are a few ways we could actually try and work around that. There's a few I would talk about. Number one, what you should probably do is use smaller, more efficient models to handle simple routing decisions or initial classification tasks, while use bigger reasoning models for more complex reasoning, in-depth analysis, or multi-step planning. This hybrid approach allows for more optimal resource allocation while maintaining quality when it matters most. That's one. Second thing we've seen a lot that works well for customers is implementing progressive enhancement techniques and escalation paths, which enables workflows to start with faster lightweight processing and escalate to more sophisticated models only when needed, not for every single scenario. What we've also seen is using model fine-tuning could really reduce your latency and inference costs while maintaining quality. And Hannah will talk about that in a little bit. Fundamentally, what you need when you're thinking about these applications is a very good evaluation system, which does not look through the entire application alone, but is tailored for agentic applications. You should be able to evaluate performance at every single step of your process. You should be able to support multiple test runs to account for randomness. You should be able to do all of that. You should be able to evaluate your tool call arguments, tool results, final answer, as well as adherence to the agent's original plan. As we build more and more AI agents, we've seen customers face a lot of challenges. We've seen development teams struggle with complex technology stacks and infrastructure setup. Operationally, managing multiple agents and orchestrating complex workflows is extremely challenging. Security and control requirements add one more layer of complexity, think governance needs and compliance requirements. At the same time, as we've all seen, the rapidly evolving technology landscape, we see new things emerge every single day, makes it hard to stay current while maintaining production systems. And this is where Amazon's Bedrock platform comes into play. For developers, AWS is providing the most comprehensive toolset that empowers users of all abilities to create, deploy, manage, and scale high-performing AI agents with ease. You could be using fully managed agents, or you could be creating your own DIY agents with Amazon Bedrock. You've got the model choice, you've got Bedrock agents, you've got Bedrock workflows, you've got multi-agent collaboration. As I said earlier, the choice of models is extremely important for agentic applications. Amazon allows you a huge choice of models for building applications. You've got models from AI21 Labs, from Amazon, from Anthropic, from Meta. We recently got access to Anthropic Cloud models, Opus 4 and Sonnet 4, which got released just last week on Amazon. At the same time, we've got hundreds of publicly available models through the marketplace as well. At this point, we'll go back to Hannah. Hannah, over to you.
Thanks. All right, let me see if I can take over and share. Just a minute here. I'm gonna take over. I'm gonna take over and share, and then I'm also gonna switch midway through, and I'm gonna make Anurag very nervous by doing a live demo where I showed it to him earlier today and it immediately broke. So everybody bear with me here a bit. All right, it looks like I'm doing my other view, right? Can you see my PowerPoint or the presenter view?
The latter.
Okay, hold on. All right, I'll try this one more time, and then if it does the same thing. How's that? Is that better? Great.
Yeah, sure.
Okay, so I'm going to talk through a little bit in terms of the optimization side and actually putting this into practice. So like I said, I'm going to do a live demo here, so that's kind of more of the tutorial part. And I'm just going to walk through a little bit more context of what we're going to show there. So just going back to the piece that Anurag mentioned earlier in terms of what are we looking at when we're talking about optimizing, a lot of it goes back to that cost, latency, and performance or kind of capability outcome. And that's really important when we're looking at agent workflows is, if you can run something in production with, you could probably grab a super performant, really large model off the shelf. But that's not going to really optimize in terms of your cost and latency kind of elements. So you want a solution that kind of gets at all of those. And sometimes it's a mixture, which we'll talk about in kind of the multi-agent approach. Some other capabilities that are really helpful to get to more, just optimization that you can kind of pick up and leverage pretty easily. One is model distillation approaches. So a really simple version of this can be like a distillation where you leverage a teacher model that's able to provide outputs that you then use to fine-tune a student model. And that approach can work really well, especially for applications like Q&A with a retrieval augmented generation kind of a setup. Also using intelligent prompt routing strategies to send queries to smaller, faster, cheaper models that can help save a lot of costs as well as latency. And then things like prompt caching can really be big wins. And these are things that I think we should expect to kind of get better over time as we have more of these systems in place, we'll find more ways to optimize. But getting to that model choice and being able to model right size is something that we see with a lot of customers that we work with. In terms of the agent workflows and building blocks, I think we've also seen, as I think the panel before ours and Anurag talked about a lot, this space is evolving so quickly. I think we're seeing a lot of people having to roll their own stuff, kind of build their own solutions, that now we're finally seeing some of the foundations and places from our side on the AWS side come in and help remove some of that undifferentiated heavy lifting that's not really adding to what you're building as much as things like memory management and session handling and security and guardrails and all those pieces. And so that's where the Bedrock platform can really come in and help give you an easier place to kind of build these things where you can focus more on the use case that you're building, the agents that you're leveraging, and less about, kind of all of the orchestration and management and updating and things like that. So, by the way, I know the last session was very focused on MCP, and I don't have it on this slide, but I will note that the agents in Bedrock now also integrate with MCP. So we're seeing a lot more of those integration pieces and making it a lot easier to build really flexible kind of solutions here. So just backing up a little bit and kind of giving you some context on what I'm going to demo in a minute. So agent workflows, a kind of concrete example could be that you have an agent that helps with answering questions like HR questions about time off. So maybe that agent has access to a database that has details about time off kind of things. And you can ask it questions like, all right, what vacation balance do I have left? Can I book my sick time, vacation time, etc.? And you can easily expand this and add more knowledge bases to the agent system. So, okay, let's say now we'll also say, I want to be able to ask general questions about our HR policies beyond just kind of our time off kind of things. And then maybe I also want to add in leave of absence kind of thing. So I want to maybe start a new leave of absence or extend a leave of absence, et cetera, et cetera. And that can talk to its own knowledge base and take actions. But at some point, what we've seen with customers that we work with is like you can kind of take this a little bit too far. And if you try to have one agent that's like this do-it-all agent that has access to all these different knowledge bases and actions and things like that, there's a risk that you have more hallucinations. It's harder for that agent to keep track of what it's doing, and the outputs can be questionable. And then the other thing that happens is to be able to do this, you probably need to use a really large, super performant model that's able to reason through and figure out what it needs to do. Your prompts are also probably getting super large and bloated and having to give it really detailed instructions so that it can navigate all these different things. And so what we're starting to see, just to get through all these challenges that come up, slower, more expensive agents, confusion, figuring out like how to code it and maintain it and update it and things like that. That's where we have started to see this movement towards more focused agents. So one example of this would be just, maybe we have single agents that do all these things. So maybe you have one agent that manages the time off stuff. Maybe you have another agent you talk to for leave of absence stuff. And maybe you have another agent that you talk to figure out, like, how do I get promoted? And that talks to the HR policies kind of knowledge base. That's great. But then at some point, you still end up with these kind of siloed, limited agents. The user experience ends up being pretty splintered because you've got to, your users have to keep track of where do they go to do some of these related things. And it's also, if you want to plug these together, it can be kind of challenging to do that orchestration yourself. And then you aren't really solving these more game-changing problems. I think I saw a question asking about sorry for missing the acronym here. I think like RPA or like a more of like kind of process automation kind of pieces. And so what we really want is to leverage the reasoning power and connect these things together to be able to solve really open-ended, exciting problems. And so that's where a framework like Bedrock multi-agent collaboration can come in. And so this lets you kind of pull these things together, assemble your agents, connect into knowledge bases, plan and execute tasks across agents, being able to have unified conversations that share kind of that knowledge and context, and have observability and guardrails and security and privacy across all the agent workflows. So instead of having, your separate applications, now we end up with this current paradigm of more of like you could have a supervisor agent that helps to orchestrate across these. So when you ask a question like, hey, do I have vacation time left this year? It knows that it's going to go to its time off specialist agent. If somebody comes in and asks for a leave of absence, it's going to go to the leave of absence agent. If it asks about this promotion kind of stuff, it can go to HR policies. And so you're talking to kind of the supervisor that's able to dole out work to other agents. And you can have more complex workflows, agent to agent kind of things as well in here, but this is kind of a simplified example. So from a user perspective, that makes it a lot simpler. I am going to go ahead and switch over, and I'm going to do, luckily it's not a super complex demo, so hopefully it'll just work and be fine. But let me go ahead and switch my screen share real quick. Okay. And this is just a quick little Streamlit demo on top of agents that are running in Bedrock. So that's what we're going to go through. So this is, oops, so I meant to actually bring the slide up to highlight here, but basically what we're going to use as an example, I'll show you kind of the flow in Bedrock so you can see it, but we're going to use this mortgage assistant, kind of an example. And so what it's going to do is it's going to be basically a user can come in and ask questions about their existing mortgage. They can ask questions about filling in an application for new mortgages. They can ask more open-ended questions about mortgages. And so I'm just going to go and show you real quick what this looks like kind of under the hood in the AWS console. So this is in Bedrock. So this is the main Bedrock console. There's like a million different things in the Bedrock console, but I'm just going to go to the agents dashboard. And so you can see for this demo, I've got 4 agents in here. And I have this kind of like top level mortgage assistant agent. That's my supervisor. And then I've got a mortgage application agent. I have the existing mortgage assistant. I have a general mortgages question agent. And then I have the supervisor that's supposed to be kind of overseeing everything. And then if I go in here, you can kind of see I've got a description of it. I can see different versions of this agent. And I can actually go in here and look. I'm just going to go into the edit mode. And you can see I've got instructions that I actually give to the agent that I want it to act as a helpful mortgage assistant to allow seamless conversations across a few different domains, current mortgages, new mortgages, general mortgage knowledge. And I can also go down here and I can see the multi-agent collaboration that it's enabled for this one that is working with 3 agent collaborators. And so if I view that, you can kind of just see what this looks like. And so here's my supervisor, and then here's my general mortgage question agent. Here's my application agent. When they have action groups, that means it can do different actions, like go out and reach out to knowledge bases or call like make function calls and things like that. But these are kind of just, these are my different agents. And the nice thing from an optimization standpoint is these don't have to be the same model. They can all be really task specific, domain specific, targeted models, which means that if I don't have to use a giant like do it all model for all of these, I'm probably not going to. I'm going to try and like make these as small and fast and cheap as possible, depending on what they're doing. And so this gives you a lot of flexibility to be able to really dial in the full solution. All right, I'm going to go over to my little Streamlit app. So this is just kind of like sitting on top of that. And I'm going to go ahead and put in some questions. And this is the part where it broke earlier. So Anurag's like on the edge of his seat right now, watching to make sure it actually works this time. All right, so I'm going to ask it, what's my balance in next payment? Okay, so the first thing it does is it figures out which collaborator it should use for the request. So in this case, it figures out, hey, I need to use the existing mortgage assistant. And so that goes and it calls and figures out, it makes a tool call to get mortgage status. That gives it all this information, and then it's able to come back and say, this is what actually comes. All this is like all the thinking in the background you wouldn't necessarily show to a user. But the response at the end is, hey, your current mortgage balance is like $150K. Your next payment is $1,579. And then so I can also ask things like, okay, what are the rates looking like over the past 2 weeks for new mortgages? And so this one realizes, hey, I need to actually call a different agent for this. So it figures out I need to call the mortgage application agent to figure this out. And so it's gonna invoke another tool. It's going to invoke the get mortgage rate history tool for and these are the inputs that it's going to give. It's going to give, hey, I want the rates for the last 14 days. And then it gets this tool response. And then it goes back and analyzes that and provides this answer. So, hey, it looks like the mortgage rates have been relatively stable, fluctuating between 6.38 and 6.45. Most recent rate is looking like 6.45 as of May 26th. And then the lowest rate was at 6.38. And just minor day-to-day variations. And so, maybe I've been thinking about, I got kind of a high interest rate on my mortgage. So, I'm wondering like, when do people usually refinance? Like, should I refinance as soon as it's lower than my current rate? So I might ask a question that says, hey, what's your general guidance for refinancing mortgages? So for this one, the supervisor is going to realize, hey, this is like a general mortgage question. I'm going to send it to my general mortgage question collaborator. And it's going to use a knowledge base to get this response. Here's the knowledge base. Here's what we get like in our retrievals from the knowledge base that has some information about when you refinance. And then here's the final agent response, kind of putting this together. So general rule of thumb says, historically, like 2% was the benchmark. Maybe 1% could be okay too. So somewhere in that 1 to 2% mark is probably a good rule of thumb. And then it gives some common reasons that you might refinance. So you might refinance to get a lower rate or a shorter term, or maybe to switch mortgage types, things like that. And then it warns me like, hey, you should consider like the total life of the loan and all of these other things that can be risky before doing that. So now I'm going to ask a little bit more of a complex question. I'm going to say, all right, well, what interest rate do I have on my existing mortgage? And then how does that compare to rates for new mortgages? And so for this, it's going to have to go, it's not going to be able to just farm this out to one other collaborator. So it's going to go into its supervisor mode to kind of figure this out, and it's going to break it into different steps. And so it realizes, hey, I need to gather information about the existing mortgage and also current rates. So I'm going to talk to both of these agents simultaneously, since getting that information doesn't have to be sequential. It can just go and actually make those calls in parallel. And so it's going to go to the existing mortgage agent. That's going to pull the current status. And then it's also going to go to the application agent that's going to get the current rates. And then it's going to go back and see, okay, how does that compare? And then it's going to, now that it has the information, it can do the comparison, and then here's the final response at the end. So it says, okay, I've got an interest rate right now of 8.5%, which is pretty high. And it's higher than the market rates today, which are 6.44% for a 30-year fixed, or a little bit lower for 15-year. And then it says, hey, since the current rate is significantly higher, you might want to explore options for refinancing. And it offers, if I want to keep talking about that. I'm curious though, if I lock in, how about if I lock in the rates today, what would my payment be for my my 151K loan? And so for this one, it's going to go back to the application agent. It's going to look at the rates today. And then it realizes, hey, I actually should use a Python. I don't know if you can see this. I'll actually use a Python code interpretation to make sure that the calculations happen accurately. Because one thing, LMs are not always the best at math. And so sometimes it's actually better just to send it to a code interpreter instead. So you can see it actually decides to use a code interpreter and do a calculation based on interest rate formula to get a payment estimate here. And then it decides, okay, I've got that, I'm going to summarize it. And so it gives me comparisons for, here's what monthly payments would look like if I refinance. And gosh, that's looking attractive. So I might think about that since my current loan is a lot higher. So this just kind of shows you, an example, kind of a more concrete example of, how this kind of multi-agent collaboration can work and how you can, it's very extensible, right? And it's also updatable. So if a new model comes out that is, better than one of the agent models I'm using now, or more favorable in terms of cost or latency or ability to do some of these things, I can easily go in and I can just go and click into my model and I can just go and edit it and say, hey, I want to use the latest and greatest model and kind of keep optimizing it from there. So I think what we're seeing is, again, all of this stuff moving up and evolving really quickly. But I think in the background, what's also happening is we're getting a lot of these helper tools and frameworks and foundations that will make it a lot easier to build these kind of complex workflows over time. And we're able to build things that can reason and to, have this kind of collaboration. I think right now we're a lot limited in like our imagination of what to build more so than the tooling to actually make it happen. All right, I'm gonna switch screens back so that I can pull up. I've got a couple QR codes I want to pull up to before we end. Let me know if you see the slides again, the correct one.
See the market slide, yes.
Great. Okay. So this is the slide I didn't show you before, but this is kind of like, before and after, right? So without this kind of agent workflow, you could see this replacing or offsetting some like waiting in line on a phone call to talk to an agent and sitting through heavy call center volume, not being able to just kind of have this on-demand chat situation, or just having kind of limited or static data views. All right, I didn't need the recording because that actually worked, so I'm going to skip through this one. I want to just put up some content for folks who are interested to learn more about how to do this. I think a good place to start is to look at workshops that we have. So we have on the left-hand side is like the general Amazon Bedrock page. On the right-hand side is an Amazon Bedrock workshop. AWS workshops are really handy just to like walk through all the steps of like building these yourselves and get experience of not just the toolings, but like how you put these kind of use cases together. So definitely recommend checking those out. The other thing I'll just put in a quick plug for Anurag kind of introduced our Generative AI Innovation Center team at Amazon earlier, and I'll just put a quick highlight that we are hiring for a range of roles from Gen AI strategists, data scientists, deep learning architect, applied scientists, and ML engineers. So if you follow this QR code, that should take you to the Amazon job site that kind of can show you those roles that are open. I'll leave that up for just a second. And then I think we'll stop there and then maybe take a look at some of the Q&A that's coming in if we haven't gotten those answered yet.
I think we've been ferociously trying to answer a lot of the questions that have come up in the chat. I wonder if there's any you'd like to handle live verbally as well, Hannah? I think there's a couple which talk about RLHF, which is RLAIF. You want to take any of those, Hannah?
Yeah, let me see where those went. Can you read out the question? Oh, I see it. How about, okay, I think I see one. Okay. How about fine-tuning with RLHF versus RLAIF, reinforcement learning with AI feedback? I know fine-tune with RLHF means DPO trainer, PPO trainer, so on. How about if we do it, if we want to fine-tune with RLAIF? What are the differences? Yeah, I mean, I'll talk a little bit maybe about just generally like customization trends that we're seeing maybe. So I think especially GRPO is one that like people are very interested in leveraging that for efficient kind of reinforcement learning approaches. We've also been seeing more DPO. I mean, I think in the past, RLHF had been like had been a little bit maybe more variable in terms of results compared to something like fine-tuning, but I think that's not always the case today. And I think that's with some of these approaches, it's getting easier. I don't know that I have a lot to say specifically or concrete data points specifically for RLAIF, but I will say in terms of like leveraging LLMs as like inputs and judges, for instance, for customizing models, I think we've seen a lot, like for instance, even like maybe a more simplified case of like when you're trying to customize a model to do better at a task, either improve the output or improve the outputs while reducing like the size of the model and the quality and the latency and cost and things like that. One of the things is like you also want your like the evaluation benchmark that you use is really important. You're usually not just trying to optimize for an off-the-shelf general benchmark because a lot of the models have already been optimized against those off-the-shelf benchmarks. So a lot of times people are trying to optimize and improve their model through customization, like RLHF or fine-tuning or continued pre-training or et cetera, all these like post-training kind of approaches. They're trying to make it better on their use case. And that could be to say like, hey, maybe I want the style and tone to match my corporate style and tone, and I don't want to try to bake that into a really long prompt. Or I want it to be better at this specific tool usage, or I want it to be better at I want it to figure out, like, know how to do my proprietary SQL language, something like that. But you need some way to measure that. And so for instance, like a common place where we see like LLM judges coming in would be that you are fine-tuning a model or you're modifying a model because you want it to like the responses for your Q&A, you want it to have better clarity or match that style and tone or do something. And sometimes for those like more, I want it to be better, a little bit vague kind of use cases, LLM judges can be handy because otherwise your fallback is to like leverage human evaluations, which really slows down the iteration cycle. So one thing to be cautious about though is that different models might have biases in terms of which responses they like. And so like in LLM judges, we've seen funny things where like sometimes if you are judging the outputs from like one family of models, if you use a judge that's from the same family of models, it might either like its own family of responses better, or it actually might like them worse. Like we've seen some models that are like prejudiced a little bit against their own responses. So I think just maybe one thing to be cautious about with AI feedback is to try to understand those biases and then find ways to have oversight and review that carefully so that you feel like you can trust the results. I don't know if that exactly hopefully that got somewhere close to what they were looking for there. Anurag, did you see any other ones you want to call out to talk through live?
I think there was a few which did talk about, I think, evaluation overall. I think you should have touched on that already. There was a couple which talked about how do we think of cases where the orchestrator is not able to figure out which agent to call? And that's a very real scenario. I think there is no good answer, I think. In the end, what you do need to do is make sure you evaluate the classification, if I may, with a high level of precision. And in such cases, depending on the complexity of the task at hand and how risky that actual task is, you might have to hand it off to a human agent eventually if there is no way to figure out the right step.
Yeah, I think that's a super good call out. Like you could either have the supervisor be like, well, I'll send it to my best agent that I possibly can, or, a good way to do that is just to say like, hey, let me hand it off to a human. This, like it's like that, like, hey, I tried, but I don't know how to do this. Let me, pass it off. And then that way your human agents are they're covering the stuff that's like more complex and needs like kind of a higher touch as well.
And it's like very similar to like if you think of the customer case scenario, you have like somebody calling their manager to like say, hey, I don't know this answer.
Yeah.
Let me call the supervisor. That's
Yeah.
basically what it is in a more agentic scenario.
Yeah, exactly.
Yeah, I think people wanted the QR codes back up there again, Hannah.
Oh yeah. Let me go back. Mm-hmm.
And then there's other questions. I think there's some questions around cost. I think costs are very dependent on the actual use case. So there's like no one way to say how would your cost compare to a traditional application. I think these are very unique applications. You'll have to evaluate on a case-by-case basis, like how your application stacks against something else that might be equivalent. In the end, what I would say is you should always work backwards from what works for the enterprise. If there's not a business case, you probably not be able to set up the application and scale it up. In the end, it has to be cost effective and should justify the investment and the ROI.
Yeah, I think that makes sense. Maybe the other one I'll answer quickly. There's a question for whether Bedrock supports like a setup where instead of you just have a supervisor or like a parent and some children underneath, like a more complex, like maybe grandchildren or people talking. And the answer is yes, you can do you can do much more complex, like nested kind of setups. The one that I showed is just a very basic, like parent and 3 kids, but you can definitely do more complex nested kind of structures as well. And then I have the QR codes back up. So I got that one. I don't know if anybody wanted the other one again, but let me just also put that back on the screen in case. I think we did that one. Any other ones, Honor, you want to call out?
No.
Great. Okay. Well, I'll just say thank you again, everyone, for joining us. It was really a pleasure to be here and happy for the opportunity. Maybe we can throw our LinkedIn's in the chat somewhere too, if you want to reach out and connect after this as well.
Of course.
Okay. Thank you so much, Hannah and Anurag. Yeah, have a great rest of the day, and we are going to close day 1 of the conference.
Thank you.
Thank you.
Thank you all. Have a good day.
Okay, so we are going to go ahead. I will take maybe a minute or two to close the first day of the conference. We have another day tomorrow where we have some exciting content that is coming up. We'll start the day with a fireside chat between Luis Serrano and Josh Starmer. We'll start with that for about 45-ish minutes. We'll then go to tutorial on building vertical specific AI agents. We will go ahead and then after that, we'll have another talk by Mozma from Microsoft. You saw her in the second panel today as well. And then finally, we'll close day 2 with a talk from Paige from Google DeepMind. So with that, I'm looking forward to seeing all of you tomorrow. Thank you all for joining today. Have a great rest of the day and have a good night for some of you. I think I know many of you are in a very different time zone.